Very good morning, all of you. So we are starting with information retrieval for software engineering track. I'm handing directly over to the session.
Good morning, everyone. So I just start on it. I'm really sorry. We apologize for I think okay, that's fine. Okay. I'm presenting an overview of the track which we have been running for 3 years now. And unfortunately, we have mostly online participants because the students have exams. They could not travel, but they are there, and we also have some recorded videos. And we'll also talk about the pathway and the roadmaps for the track for the track. So, if we get into the actual work very quickly, and maybe I will just give an overview is that what are we trying to do here? So, we have legacy code bases based on bare metal languages like C, COBOL, and that actually comprises of 70% of the mainframe systems which are running everywhere and which runs well. So, there is a saying in the company that if your code runs well, don't fix it. I mean, just don't try to upgrade it or something. So, but that's a very inherent problem in various industries and companies which we have seen. So, what we are actually aiming here to have a LLM based or LLM assisted comprehensive metadata generation system. So, what do I mean by metadata, and what is the metadata we work on here? So, we work on code comments. So, by code comments, we mean we can have function level comments, inline comments. We can also have fine level comments. Now, how do we evaluate the quality first? So even to generate comments, we need to understand which comments are useful and not useful. So, I mean, if we move on, so what are we going to do? Let's remain here for task description. So we have a set of code and comment pairs, and we use industry experts, a semi-supervised annotation framework, which actually tries to evaluate few quality attributes about the comment, whether the comment talks about various categories such as exception, such as linking navigation-based information. Does it talk about a working summary? Does it talk about algorithmic patterns? And they annotate those quality attributes. Apart from that, they also talk about whether the comment is redundant. That means it's very obvious from the code what the comment is talking about. We don't need that comment. Whether the comment is inconsistent, because in that case, the code is actually buggy and the comment talks about different bug which is not there. So that means it's a dead or stale comments. And also we talked about superfluous comments, which is very verbose and we don't require such a level of comments. So these are the quality attributes which have been annotated, and we have been able to come up with a data set of 20,246 comments, which has been then further analyzed into useful, partially useful, and not useful comments. So based on that, what is the task is that they will first do a classification problem to see whether they can actually come up with features, different sets of features which help in classifying the comments into useful, partly useful, and not useful. And further, what is the very important part here is that we actually use LLM to generate more code and comment pairs. So in that way, we give the LLM that, okay, fine. So this is like a prompt would be based on example. Like this is an example of a useful comment and not useful comment. Can you actually take these set of comments and generate the labels for it, whether it's useful, not useful, or partially useful? And using this augmented data set, we again revamp the classification to understand whether LLM actually can generate robust prompt as humans so that we can scale up this process. So what this time we had 14 teams, even though like many, which has had 45 experiments and runs submitted. And what we see here is like a diverse array of participation from various academic institutions. This one obviously we had a little bit less participation from industry, but we have been running this track in coordination with three companies, which is Mentor Graphics and which is a Siemens business, like and also Peak Indicators from the UK and some parts of India systems. So we actually have run it with them, and these data sets which we have generated using LLM has also been evaluated by them. And so we have around 6 developers who work with us, industry experts also. We can work with developers. So this is a complete participation. Out of them, we have selected 5 for presentation here, which are among the top 5. And what we see is that people have actually the students have come up with various form of machine learning algorithms. This is given overview that these transformers ranging from name bias to RNNs. They've tried all sorts of algorithms, and the major part of the track was the analysis behind it, why are these being tracked, and also they have been using various features based on code embeddings. And nowadays we have so much code embeddings like code word and code llama. So I mean, even the embeddings which is generated from large language models. So all of them have been used. And so basically, this is the total team which and how they have performed. So I think that's we can just and the type of model they have used and everything. So we can just comment that for now. So I mean, I would want to pass it on to the first video, but then I think Laksha, are you there?
Yes, ma'am.
Okay, so would you like to present it in 4 minutes? You don't have much time, so you need to wrap it up, your results section. You would like to present it online.
Okay. I will share my screen if.
Share your screen, and after that, Advaita, you can also present it online in 4 minutes, okay?
Okay, ma'am. Just a second. Ma'am, if you can stop sharing, then I can share my screen.
Yeah. Can you share the screen now?
Yes. Just a second.
But keep it to 4 minutes, please. I'll stop on the results. I've already given an overview.
Sorry?
I've already given the overview, just stop on the results part in
Okay.
4 minutes.
Okay, so in this experiment, hello, I am Lakshay. For this experiment, I use random forest for evaluating evaluating the classification. If we can see if our primary objective was to measure any performance uplift if any using the augmented data set. Here I'm adding new examples using GPT-4o to create new synthetic examples and add it to the original data set that the ma'am has already told you about. And in addition to that, okay. So, if you look at the results for the original data set, the model achieved an accuracy of like 0.82 and the F1 score of 0.78. But when we switch it to the augmented data set, the accuracy was still 0.81 and the F1 score held steady at like 0.78. So there was not any there was not any performance uplift as per se, but there was a stability among the performance matrices. So but in machine learning, whenever we introduce new synthetic data in the system, it often carries a risk of introducing noise in the system, and that confuses the model, like in this case random forest, and that might degrade the accuracy eventually. But in our experiment, we did not see any degradation of any of the matrices. There was a minimal deviation in all of the matrices. So this proves that from this we can prove that the synthetic data generated by GPT-4 was of comparable quality to that of the human annotated data set. So the model accepted this new data without any loss in precision on recall, right? So we essentially validated that synthetic data augmentation is a viable option that can be used for expanding data sets without compromising the model's integrity. In cases where the data is scarce to when we want to train a model with good performance. So this is the results of my experiment.
Okay, thank you, Laksha. That was quick and very effective. Shresh, are you there?
Yes, ma'am. I'm available.
You can also share your screen and present it as quickly like Laksha did. Right? In fact, just come on to your main analysis and findings.
Yes, ma'am. I am. Um, is my screen visible, ma'am?
Yeah, it is. It is.
So, hello everyone. I am Kumar Shresh, and as ma'am has already introduced the motivation and the data set part, so I'll quickly move to the results section. So, I have used a linear SVM for the task, which is historically one of the strongest baselines for text classification, and naive Bayes, which is a fast and lightweight probabilistic model. So these are the results. So SVM without augmentation, I achieved an accuracy of 77%. with an F1 score of 77% as well. And naive based without augmentation of GPT data, I achieved an accuracy of 60%. But after I augmented the data set with GPT-5 augmented synthetic comments, the SVM accuracy still remained at 77%, but the naive base accuracy increased up to 64%. This already tells us something important, that SVM improves slightly and naive base improves more noticeably. This suggests that synthetic comments help weaker model by broadening the data distribution. However, gain remain modest overall. So this is what I concluded. And for the conclusion, so linear SVM and TF-IDF provides a strong baseline for comment quality classification, and GPT-5 augmentation gives modest but consistent performance gains, especially for weaker models like a naive base. However, for the limitations, we had that features were shallow and there was no deep semantic alignment between code and comments, and hence I could have used CodeBERT that provides more code aware and semantic embeddings. So that was that for the results part.
Okay, thank you. Shresh, I just had a question, but maybe I'll come back to you later.
Okay.
Aditya, are you there? Aditya Srinivasan?
Yes, ma'am. My teammate Adit will take over the presentation.
It's okay, but it has to be done quickly because we're running late and I want to finish time. So
Yes, ma'am.
just analysis and your final results quickly and crisply, please, okay?
Yes, I'll be sharing my screen now. Is my screen visible?
Not shared anything yet.
Oh, sorry. Is it now visible?
No, I need to share your screen. You share the whole screen?
Is it now?
Yeah,
Can you
so,
see
yeah, go into presentation mode and just talk about the results, please.
Yeah, okay. So you can see here, these are the, so firstly, our model uses it's a GNN model, a graph neural network model. So as we can see on our screen, our F1 score accuracy is 80.8% with an F1 score of 0.807. So if on the side, you can see a bar chart. So for the not useful class, we got a precision of 0.77, a recall of 0.71, and F1 of 0.74. So basically, it means that the model can accurately predict it 0.71% of the time. And for useful, we got a much higher one, 0.83, and recall is 0.87, and final F1 score of 0.85. So yeah, it tells us that we have a high recall for useful comments and a slightly lower one for not useful ones. What we also did to test the generalization of our model is that we have created two synthetic data sets, one with 16 samples and one with 100 samples. So if I go back to this slide, you can see on the PPT here that these are the accuracies for each of these respective tests. Now, so the 16 sample one has a much lower accuracy. This comes down to a property in statistics called variance. These 16 samples have certain patterns in them which are somewhat similar and do not cover all the patterns that the model has learned during its training process. So the patterns that are in these samples are some patterns that the model is a little weaker at predicting. But if the 100 sample one has much more variance and much more different types of patterns, so it is capable of predicting much more. So we can see this in the trend in the line chart. So this is a comparative performance with all other models. That is our results. That's it.
Okay, thank you, Adit. That was quick and very effective. Thank you. So is Vijay there? Vijay Raghavan KS?
Yes, ma'am. Yes, ma'am. I'm there.
Yeah, can you please follow this pattern and present quickly your analysis?
Yes, ma'am. Just one second. Is my screen visible?
Yeah, it's visible. Yeah. Let's go to the results.
Yes, ma'am. Can you see the PPT?
Yes, yes.
Yeah, so I'll just give a quick overview of our synthetic dataset generation. So we used rule-based synthetic generation for 500 samples, where we modified the comments based on English syntaxes, and we also generated another 1640 samples using heuristic labeling that we use the Grok Flash 3.0 Flash model. And these are the results. We had used the CodeBERT plus MLM model with domain adaptive pre-training. Since CodeBERT is very efficient in understanding natural language as well as programming language, after exploring some TF-IDF models, we decided that CodeBERT would give us the most accuracy in FN score. So when we trained on the original data, we got an FN score of 0.9193. And after adding the augmented data and removing some of the noise and errors, we got a slight decrease in the FN score, that is 0.9166. And our conclusions are that the CodeBERT model with MLM is highly efficient in predicting code comment usefulness. But generation of augmented data needs to be of good quality, otherwise the noise can reduce the FN score and accuracy. So yeah, this is our conclusion.
Thank you, Vijay. That was also very fast. Advaita, are you there?
Yes, ma'am.
Yeah, can you just also do the same thing, just present a mean analysis in 2-3 minutes so that I can go on?
Yeah. Yes. Okay.
Just the results part, go to the results.
Yeah.
Hi everyone, can you hear me?
Yeah.
Yes.
Thanks.
So,
Hello. Advaita, can you hear me just a minute? Yes, Bhaskar, we are able to hear you. So there is one direction after that, your keynote will be there.
Yeah, but it would be good if you just could quickly close it, then in 2 minutes. Yeah, please go.
yeah. So, as Sujoni ma'am explained about the track overview, so this was the leaderboard. So as you see, the Salesforce team has achieved the highest performance with F1 score of 0.91 with the transformer, and they were followed by the IIT Kharagpur team 1, which used CodeWord. And then surprisingly, we also saw that the IIT Goa team that used SVM did perform pretty well, considering it's a very traditional method compared to the expensive transformers. So these were the results from all the teams, and these are all the models that they used. So for each aspect of their code. So the Salesforce team was using CodeBERT, which was a transformer model which worked pretty well. But we also saw that some traditional models were highly effective for this data since it was clean and it was balanced. That is the useful and non-useful codes, the comments were equally balanced. So in the end, what we saw that is the transformers models were working better compared to the traditional models, and with the F1 classification of 0.91.
Okay, thank you. Advaita was also part of the overview paper team, so she had to present the results. So okay, I'll just quickly close and on the track, like what was our overall analysis. So what we now find is this is a part of the research we are doing overall, and it is a big part of the research which we are doing separately, where we have actually consistently been using design documents, the source code as RAG to generate comments. And recently we have also got a paper accepted with ICSI, where we have actually used design documents to generate code comments, and it has shown excellent results for bug detection as well as navigation-based comments. So it would be really great. I'm going to share some links, and comments are really useful, and maybe share our recent papers also. So it's just a small part of the work which we are mostly doing for brown truth annotation, scaling it using LLM, and it would be great to chat on later. I know I'm really short on time, so I will not take up any more time because Bhaskar is also waiting. Thank you so much, and I hope wish you a nice second day of fire. And thank you everyone for being here. And this is good.
Okay. So, yeah. So, Bhaskar, you are audible?
Yes, I can hear you. Yes.
So, I am handing over to Liana, session chair.
And for this next of the invite talk of Thomas Carter, who is the information retrieval researcher in Montreal in Canada. So his research focuses on development of the machine learning methods and benchmarking information retrieval systems, as well as study of societal implications of information access technology. This talk will be related to that. So he started his study as the ACM secretary and as an associate editor of the ACM Transactions on Information System Journal. He has received several awards, including ACM Secretariat Editorial Research Award in 2024. And he received a PhD in computer science from the University College London. He previously worked for 19 years in Microsoft, but now he left the the industry because his research continues more than just a job. So, his talk is entitled Emancipatory Information Retrieval, Radically Reorienting Information Retrieval Research to Resist Corporate and authoritarian capture of our information ecosystems. Let's welcome Basak.
Thank you, everyone. I hope I'm still audible over there. Thank you for the warm welcome, and super sorry I didn't realize the previous session was running when I logged into Zoom. For today, I am really excited to talk about a particular topic that's really close to my heart, something that I've been working actively over the last few years, but also for a longer time has been a product of some deep reflection about the role of IR and tech in general, and what the role that it is playing in society. I also would like to apologize for not being there in person today. I would have really loved to, but I couldn't because of some other personal commitments. But this talk is meant to be a bit of a provocation, a bit of a conversation starter. So please do feel free to reach out to me. My contact details is at the bottom of the slide. Please feel free to reach out to me after the talk if you want to have any discussion on any of these topics. Before I get started, I will also just very quickly add a little bit of a content warning that in this talk, I will be referencing and touching upon certain topics that might be triggering for many people, including reproductive rights, coloniality, classism, racism, misogyny, transphobia, casteism, ableism, political violence, war, and genocide. So with that, let's get started. So our world today is experiencing a confluence of multiple mutually reinforcing crises. And what is particularly important for us to consider in this context is each of these different kind of crises that we are faced with, each of them intersects very saliently with concerns of social justice and emancipation. So, for example, when we talk about climate change is not just a question about environmental science or ecology. It is deeply connected with questions of gender justice, racial justice, indigenous right, decolonization, and disability justice. Similarly, if we think about the pandemic, COVID-19 pandemic that the whole world experienced and continues to experience, again, this is not just a question about medicine and public health, but directly a question of concerns that touch upon caste, on labor, on gender, on disability rights, and so on and so forth. On the other side, the COVID-19 pandemic is also not just disproportionately affect people based on these different demographics or attributes, but also directly connects with the rise of a certain kind of politics, violent extremist politics, and authoritarian politics. Similarly, if we think about global inequity continues to be a big problem to this day. In some ways, it has also been increasing over last several years. But it's not just a question about the economy, the financial inequity and class, but it also then connects directly with questions of racial justice based on gender justice and so on, because the effect of this is not equally felt by everyone, right? On the other hand, global inequality also has a direct connection with erosion of democratic processes and falling into parts of the world falling into authoritarianism. So all of these different crises that we are looking at not only intersect with each other, but are also mutually reinforcing. And when we think about this, we do need to think about that complex relationship between these different crises. Continuing on, I think if you open the news today, it's every part of the world is going through different kinds of oppression, state-sanctioned oppression and other kinds of oppression. And equally, we are seeing people coming together in solidarity and rising, pushing back on some of those negative regressions in our society. So, for example, if you're talking about in the US or UK, you might think about the regression in reproductive justice, the regression in trans rights, regression in some of the narratives and discourse about immigration. And on the other side, you might also see daily on the news about people coming together on the streets or whether it be the university campuses trying to push back. And last but not the least, we are living through a period in history, at least in the, let's say, the last several few decades, one of the most violent times in history where the news, again, we don't have to look for then opening our social media online or looking at the news. We are seeing a record number of conflicts in the geopolitical landscape, including tremendous tragedies and genocides and what not other atrocities happening around the world. And so I am talking about all of these things. You might wonder, why am I starting a talk at FIRE talking about information retrieval about all of this? It is because I want this talk to be a provocation for each of us to think about the role of computer-mediated information access in this collective struggle for social justice, universal humanization, and emancipation. So that is going to be the focus of this particular talk. And I'm going to start off here by really emphasizing something that, at least in the IR community, maybe sometimes we forget, that information and access to information has always been deeply, deeply a political topic. And this is because access to information is critical to our collective sense-making of our place and relationships in this world. And it is therefore that in all through history, whether you talk about, for example, in India, if you look at our independence struggle against the British, or any other social justice, the civil rights movement in the US, or what have you, every struggle against oppression, throughout history, authoritarian forces have tried to control what information is disseminated and how. And this information access media have been the site of conflict between liberation and oppression. This has been true for traditional media, all the way from newspapers to radios to television, and it continues to be true in our today's tech online media as well. So some of this might evoke the images or sentiments from literary works like George Orwell's 1984, but none of this is in the realms of just fiction. We are seeing this happening, especially in the context of tech-mediated information spaces. We are seeing these things happening in real life today. So take, for example, the executive order in the US that had come out some months ago, derogatorily named as preventing woke AI in the federal government, to looking at the Grok chatbot from Twitter, where it was intentionally trained to spout very white supremacist and some very hateful rhetorics, directly trained to do so. As well as if you look at, for example, models like DeepSeek that refuses, for very obvious political reasons, to talk about things like Tiananmen Square and Taiwan. So this attack on our information ecosystem to capture is very, very real and playing out in front of our eyes. And so this talk is going to be a provocation for us to think about what can IR platforms look like that is for the people, that is responsible to the people, not just responsible to large corporations or authoritarian governments. And there are some deeply technological and social and political questions and challenges that needs to be addressed here. And this is something on one side, I think, obviously, because of the potential implications, can feel very dire and dark. But on the other side, also, I think not only just that we have the responsibility and an opportunity to have really positive impact on the world, but also as researchers and scientists, I think they have some incredibly important and challenging research questions that should excite us, right? So for example, like even if we start by talking about how do we design and sustain publicly owned and maintained IR platforms, or how do we imagine, let's say, search and the search result page as spaces for emancipatory pedagogy? Where do we get started? What kind of interdisciplinary, cross-disciplinary research do we have to base our work on? In this context, I actually want to mention one of these canonical works by Paulo Freire that has had a very big impact on my own on life and politics and values. The Pedagogy of the Oppressed, where he talks about, he makes a very, very critical point that I think is important when we try to think about some of these questions, is that even when you're thinking of emancipation and liberation, we must forego this idea or this image of somebody a leader who bestows that freedom or emancipates or liberates people from their oppression, as if it's similar to like somebody saving an object from a burning building. But in fact, the way we should approach this question is to think about how we can enable and encourage actual reflective participation on the part of the people themselves, and for them to help them to find that solidarity, for them to find the basis and the means to liberate themselves, and in the process also liberate their oppressors, because they are in fact also victims of the same systemic systems of oppression. So for example, in this case, how these questions might translate into more concrete research questions is like, we might think about how do we design IR platforms truly from the margin, right? So it's not about just creating an emancipatory IR platform. Here is a design, let's go implement it, and then everything is going to be okay. No, it is about, the idea is that we are thinking about building something that we do not just get to go and build on our own because we know better, but we approach it in a way where we include, and it becomes a participatory process and a process by which people liberate themselves. And similarly, and it is not just about the design of these systems, but also thinking about the ongoing governance and moderation questions of these that also needs to be then continue to be participatory and democratic. So these are some difficult questions, and I'm going to come back a little bit to this towards later part of this talk. But this is what I want to just kind of seed this talk by talking about kind of the realities of the world that is motivating a lot of this work and personal reflection on my part. Next, I want to talk a little bit about a bit of the elephant in the room, which is big tech. So, and this is going to be a bit of a difficult reflection, because I think almost many of us, if not most of us, especially in information retrieval and in the tech community, are very adjacent to big tech and the tech industry, Silicon Valley tech industry. I myself have spent almost 2 decades in big tech, and this was part of a pretty ongoing set of reflection that I'll talk a little bit more about a little later. But even otherwise, even for people in academia, you might have collaborators in the industry. You might be working with platforms and models and data sets from industry. So it is really difficult, to be honest, I think, if you are in IR or to be in the AI machine learning space, to really be completely independent of what's happening in industry here. But this is where I think it's important for us to recognize, and I really love this quote from this article, that the history of the label Big X suggests that society does not prepend the label big with a capital B to an industry out of respect or admiration. It does it out of loathing and fear and in preparation for battle. And so the question that I want to ask at this point is like, we do know about big tobacco, big oil, and big pharma. So why and how should we situate big tech in this particular context within this particular landscape? And one of the clear ways to see a connection between all of these, between these big four, and also there's, by the way, this is not the only ones, there's also big banks and other examples of these industries. And so the connecting theme that the string that seems to connect all of these is this idea of corporate capture. That what we see is in these industries is that a few corporate actors gain oligopolistic power within the industry, and then they exert undue influence to shape public decision making to maximize corporate profits while at the expense of public welfare, human rights, and/or environmental justice. And this corporate capture can take many different kind of manifestations. So, for example, one of the manifestation could be a capture of scientific knowledge production in academia and otherwise, such that the academic knowledge production legitimizes the industry framings and the narratives and those perspectives while ignoring the perspectives that are critical of industry. And we do see some of this playing out in, for example, in tech today with some of the hype around AI, as well as some of the reactions to people who have been doing, for example, in the ACM FACT community, doing some critical work and some of the hostilities that they have been facing from the community at large. The other kinds of capture that we might want to think about is regulatory capture. So regulatory capture refers to the capture of government agencies such that the agencies that are responsible for regulating the industry themselves become then subordinate to the same industry and end up producing regulations that benefit the industry rather than the public themselves. And last but not the least, another kind of capture that is pretty prominent is media capture, where the media discourse and representation of these topics themselves promote, again, narratives that are favorable to industry and sway public discourse and suppress or overlook any critique of the industry itself. And so, having talked about this, there is a large body of literature that is starting to emerge about this topic on the corporate capture, but in the tech and AI, tech and AI landscape. So, for example, Meredith Whittaker's article specifically kind of even compared the extent of tech industry's influence of AI research, compared it with the US military's dominance over scientific research during the Cold War. We are very aware, especially in the AI space, about the cross-pollination of people between academia and industry, and largely so because of the kind of, again, the dominant position that industry holds over data, over compute, and over funding, and many other resources that academic researchers and labs and the community is very, very dependent on. I'm very aware of this even from dataset perspectives. In my previous work, I had worked on MS Marco, a dataset that we were very much aware that by putting out that kind of data sets, we were setting a particular path for the academic community to follow just because the data sets are available for the work that needs to be done. And in fact, in some of our papers, we explicitly tried to recognize that responsibility and have some open discussions to recognize the role we might play, even intentionally or unintentionally, in those contexts. And while industry is trying to attract people from academia through various means, it is also suppressing people within research who have been critical about some of the things that are happening in the industry itself. So we all know about the firing of Timnit Gebru, but that was not the only one. There has been multiple similar cases. There has been multiple layoffs of teams working, doing critical research on AI ethics and so on. And so this is, again, another pattern of capture of both the incentive, the carrot and the stick, the incentives and the fear tactics in these spaces. So the AI9 report from a couple of years ago, in fact, actually called out that the concentration of economic and political power in the hands of big tech and Silicon Valley is the core problem that AI presents. And everything else that we kind of talk about, fairness, bias, privacy, those are important things. But really what is at the root of it is the concentration of power and wealth in the hands of big tech and Silicon Valley. And they go on to talk about some of the mechanisms by which these kind of power concentration happens, including talking about lobbying, talking about how certain geopolitical narratives, like for example, in the US, UK, Canada, the narratives about like, the competition with China and other countries, and how all of those narratives somehow puts that industry, that the big tech in the position of too big to fail, and in a critical position that must be bailed out, even if even if they're actual what they promise they never deliver, or if they fail. And some of this conversation, by the way, about bailing out is already happening and showing up in the news report, surprisingly. The media capture is also pretty evident. I think if you look at any media capture, any media discourse about, let's say, AI or any such topics, it is highly dominated by perspectives from industry. So, for example, there is some research that shows that, for example, in the New York Times, the coverage of AI, almost 60 to 70% of the people who were represented or interviewed or who were included in those reports came from industry, whereas only less than 6 or less than that percent of people were from civil organizations. And last but not the least, I mentioned briefly earlier about the ACM Fact community that has been doing some incredibly critical work in pushing back in some of these harms, some of these discourse, and also raising awareness of some of the harms of AI and big tech. Even in ACM Fact, there are people who are raising concern that ACM Fact itself has also, to some extent, been captured by industry because they are so dependent on big tech for funding the conferences, but as well as the participation of people the affiliation of so many people in the community who are affiliated with big tech and do represent those perspectives which are clearly not unbiased. And talking about this particular topic, I do want to spend a little bit of time talking also about, we do have, now that we're looking at this, so much discourse about AI, and especially on the AI ethics side, it is important to kind of look at the landscape of AI ethics and how it is shaping up, right? And it obviously, with any large community, it is not going to be it's not going to be homogeneous. It's going to have lots of different perspectives. But there is something here that is worth noting about some of the differences or some of the subgroups or sub perspectives that have been emerging in this area. So, for example, I talk about the ACM Fact community, which is largely a very cross-disciplinary community of not just computer scientists, but also scholars from other areas such as social sciences, law, humanities, as well as experts not typical scholars, but other kinds of experts such as regulators and policy experts, movement organizers, and they really kind of focus on the socio-technical aspects of computing, and have been doing some incredible work that I definitely would encourage everybody in IR to really expose yourself to and learn from. So that's one of the communities that has been doing a lot of critical work in this area. Then there is also the corporate responsible AI community, and I was again both exposed to, but also being part of many of such initiatives and communities myself while I was in big tech. And they have also been doing some really important work looking at kind of studying allocative and representational harms, questions of privacy, coming up with different kinds of mitigation strategies for these problems. But it is also important to recognize that while they're doing this important work, there's also certain important aspects that we must not overlook, which is that their lenses are only allowed to look at aspects that do not challenge corporate power and profit. And by accepting those terms, they invariably become complicit in ethics washing and providing cover for corporate harms. And then last but not the least, you have other communities that are emerging that were still a few years ago would have probably been considered pretty niche, like the AI safety community that has come up through a lot of backing from very powerful elites and huge capital investments, and that have some deep-rooted investments in ideologies or roots in ideologies like effective altruism and long-termism, and have been talking a lot about problems like existential risk or X risks. I can probably talk for at least half an hour on some thoughts on that. I would not have time for that here, but I do definitely recommend a couple of papers for anybody interested here to look at. One of them is the Shazida Ahmed's paper that does a really amazing job of analyzing how the AI safety community was constructed through online communities and through competitions and prizes and AI, future prediction and all of these different activities and other ways that the social practices that built this community together and tried to then get legitimacy within the academic landscape. And similarly, the other paper that I would strongly recommend is Timnit Gebru and Emile Pitores's paper on the TESCREAL bundle, which really does a deep dive on this kind of really problematic group of values and ideologies, including the effective altruism and long-termism, and some of their connections with old school race science and eugenics and so on. So definitely a strong read, these two critical papers. And this kind of then leads also for us, I think I would like to encourage us to think about the values that are encoded in our AI community itself, right? And there is also, again, some research, some literature on this. So for example, Abiba Berhane and others and her co-authors have written a paper where they specifically look at and find that one of the dominant values in the AI community is about centralization of power. And another example that kind of pops up, especially now that so many, hear these words AGI and super intelligence have become so common. It is also very easy to look at these papers and almost immediately either find a reference to old school, really now, discredited race science, or at least references to other papers that they in turn end up citing and again, energizing some of these very problematic ideas about intelligence and so on. And one thing to kind of take away from this is that this is not coincidental. This is actually very strong reason why any discussion about intelligence will somewhat fall back into this trap of the old school race science and IQ and so on. But that is a broader discussion, but that is also, I think, is instructive for us about how we think about AI or these technologies and how we should frame them in public discourse and also within our own work and communities. And none of this is happening, when we talk about some of these values and ethics of the community, they're not happening in silo, right? We have seen enough evidence in recent years about in big tech and Silicon Valleys leaning towards authoritarian tendencies, very openly working with authoritarian governments across the world, as well as certain people, very high profile people from big tech and Silicon Valley, openly promoting ideas of kind of post-democratic worlds and kind of rise of re-rise of authoritarianism and so on. And so these are, I think, important, while difficult, but important things for us to reconcile as being part of this community. What we cannot do is 10 years or 20 years from now, look back and say, we didn't know. And so this is where a lot of the reflection that I talked about led me to, after almost 2 decades of working at Bing and Microsoft Research this summer, I made the decision to leave the industry in objection to both the harmful practices of the industry and especially in today, their complicity in the ongoing genocide in Gaza. I have also, as an IR researcher, thinking a lot about the role of AI in information access, and specifically, thinking about the impact of AI, generative AI, especially on the information ecosystem. So, for example, the impact of now that we have the ability to have, really low-cost generation of derivative, low-quality content, and what those implications are for how these technologies may be employed to shape public opinion. I would actually recommend, by the way, there is a paper that's not yet published. It's in a working paper, Generative Propaganda, by one of my ex-Microsoft Research colleagues, Madeline Depp, and some of her other colleagues. And this is a really, really good paper where they studied during the last election year in Taiwan and in India. They were on the ground looking at the role that these technologies were playing in the elections, and they had some really, really interesting and deep findings in that. But there's also the ecosystem disruption, not just from the production or pollution of on the content on the web, but also in terms of changing some of the economics on the web. For example, kind of jeopardizing what is often called as the grand bargain at the heart of the web, where websites like Wikipedia and Stack Exchange provided rich content for search engines, and search engines in turn send traffic back, whereas now these chatbots are either regurgitating content from these websites that they have been trained on without attribution, or even in case of RAG, minimizing these links in the SERP such that the click-throughs of these have significantly reduced. So this is on the kind of the content side of things, but also the one that is really and going to be a focus of this talk is the question about AI persuasion. So we have always in IR considered that, with these centralized information retrieval platforms, these platforms do have significant power in censoring, let's say, certain kinds of topics and content. But whereas these content were typically involved, discrete things like particular documents and results not showing up, I think we are now facing something much more severe, both because of where the technology has landed, as well as some of the realities of the geopolitics around the world that has changed over the last decade or two. So on the technology side, we are talking about these platforms that holds massive amount of user behavior data, and now they have these technologies, generative AI technologies, that can really produce persuasive language. And this is some work even years ago, more than 10 years ago, people from our own community have been looking at this and had pointed out that even the slightest subtle changes in language can actually play a big role in influencing people's opinion and how open they might be to certain opposing perspectives. And now the third piece of this puzzle is the technologies around alignment, model alignment. And this is something we saw with, if you look at Grok and the kind of espousing kind of white supremacist narratives, it's like these models can now be really trained to particular kind of value systems or prompted certain ways to kind of espouse certain kind of politics. And so combining these two things together, I think we are actually facing, and the technology is already here, that these platforms are now becoming effective tools for mass manipulation. And this is something that the community has been waking up to. There has been a bunch of research, including from big tech, that has been calling out the dangers of AI persuasion, but we do have to go a very long distance to address this, right? So imagine every time now you searched online or accessed information via your digital assistants or what have you, the information was presented to you exactly in the form most likely to change your political opinion or your consumer preference. Now, that is the kind of power that I think I want to really emphasize is the dangerous power that we are now seeing in the hands of big platforms. And even if you were to imagine that these platforms were good citizens of the world, by concentrating that kind of power, you're making them a target for authoritarian governments to seize that power back, or kind of through regulations force them to behave in authoritarian ways. So that is concentration itself. It is not about good or bad people. It is a structural problem when we have that kind of power over influence over democracy. And so we are seeing across the world calls for recognition of these problems and call for change. Some of it is taking the form of digital sovereignty conversations happening in Europe, happening in Canada. There's also call for kind of free web search platforms. And I think this is both an important moment for us to rise to the call, but also an opportunity for us to really do some significant work in terms of thinking about what public service information access might look like. And so with that, I want to kind of transition into the third part of this talk, which is to talk about a little history of IR itself and how we have thought about our responsibility towards society. So it kind of feels a bit I don't know, maybe inspiring or even difficult to kind of imagine this, but if you think about this paper that many of you might be familiar with from Belkin and Robertson, talking about the responsibility that IR owes to society, this paper was published nearly half a century ago, right? So this is not a topic that is new, but it is also true that I think a large part of this only got traction very recently, especially in the information retrieval community. I will be amazed if I don't point out that some of our adjacent communities like information science, human-computer interaction, and others have been looking at this much closely and rigorously for the last few decades. But definitely in IR, I think a lot of these focus really became from very recently, around 2018, the SWOL workshop and also the 2019 FactsIR workshop were the kind of critical moments when people were talking about this. And what followed has been a lot of critical and important work around fairness and privacy. But what is still missing is, however, this work has still, the community has largely been reluctant to acknowledge the saliently political nature of this work and to challenge the underlying colonial, cis-heteropatriarchal, and capitalist values that today still continue to critically shape the field, to shape the field. And even if you look at, like, certain special tracks that we've had, let's say, for example, ECIR, IR for Good, or WebConf Responsible Web, KDD, Responsible AI Day, or this bunch of others. In all of these, if you pay attention, they've still kind of, like, talked briefly about fairness and privacy and other things, but still stayed away from the deeply socio-political question about what is social good. This year, by the way, with my co-chair, Maria Hers, for the ECIR IR for Good track chairs. So we both are serving as track chairs. We actually specifically decided to take a look at this and both drive towards certain clarity of how we define social good, which we did as IR research and practices that contribute toward realizing more equitable, emancipatory, and sustainable futures, as well as try to think about how these discourses should become part of our scholarship process. It shouldn't be up to some people to say what is social good and what is not. This should be a conversation happening within our scholarly processes. And so one of the things we introduced this year is asking papers to include theories of change for their work, but they talk about how they think their work will have social impact. And then that opens up then follow-up papers to analyze those and have other kinds of ways to have those discourses. So it's one of the ideas we are trying out this year, but there's obviously a lot more different kind of experiments and work that we need to do in this area. There has also been other people who've been making these calls. So, for example, in the Rexis community, there is the Normalize workshop that has been trying to raise awareness about the implicit values and norms in our communities that shape our research. There is the Beyond workshop that has been pushing about kind of recognizing the interdisciplinary nature of our work and trying to, again, make those connections back. And also, I've been lucky to have certain conversations at both SWIRL and the ECIR Futures workshop last year around these topics. In fact, one of the things that I really kind of appreciated is at SWIRL this year, we explicitly, the working group that was looking at the social impact side, decided to change in comparison to in SWIRL 18 last time, the topic was fact IR, fairness, accountability, confidentiality, and transparency in IR. This year, we specifically made a point to talk about centering societal, democratic, and emancipatory values in IR research to really kind of put an emphasis of getting to the core of the issues and the kind of the changes that we would like to see in the world. So really, the question then becomes what I've been trying to emphasize through this talk is what should IR research focus on, right? And to recognize this, this friction between the need of the society and the need from big tech and Silicon Valley that we are kind of balancing in this space. And what this talk is a call for us to recognize this need and really talk about what a dedicated research agenda would look like for IR that is deeply situated in the societal needs of informed citizenry, of reliable health information, of social justice. And towards that, this is the last part of my talk. I want to introduce the work that I have been doing over the last couple of years, thinking about some of these framings. And one of the framings that I gravitated towards is this idea of emancipatory information retrieval. I do want to say that in spirit of, again, not trying to say this is the one answer following Freire's, the same values. I would say that this is one of the frames that I hope helps us, but also I do think it is not the only, there is nothing special about this particular framing. I think there are many other framings that could equally be useful and should coexist. And this is more of a call for both to look at emancipatory IR and think about the research agenda under this, but also think about what is the other thing that maybe emancipatory IR does not capture. Maybe it doesn't do enough about environmental justice and other things, and those should also be additional frameworks that we should be talking about. So what is emancipatory IR? I know this is way late inside the talk to define the the title of the talk itself, but that was really intentional. So emancipatory IR, I define it as the study and development of information access methods that challenge all forms of human oppression and situates its activities within broader collective emancipatory praxis. So emancipatory here signifies the moral concern of universal humanization of all peoples and the elimination of all conditions of oppression to create the condition under which we can collectively flourish. So to get a bit more specific about this, and this is one of the things I like about this framing is I hope this framing is both at the root, something we can all agree on and find solidarity in terms of universal humanization and universal struggles against all forms of oppression. But at the same time, giving us the mechanism to then directly critically talk about what is the systemic human oppressions and topics of colonialism, racism, patriarchy, casteism, transphobia, ableism, religious persecution, and so on and so forth. Last but not the least, another important part of this definition, which was very, very intentional, is this last part that says situates its activities within broader collective emancipatory praxis. Because the thing that we have to be careful about is we don't want this research to be just research for research's sake. And to be honest, I would say this is actually true for some of the research in fairness and other aspects, which even I am personally, I would absolutely confess that I have also been guilty of certain kind of research that after you look back and it is really hard to see how this research would have a real world impact. So we do want to, in this emancipatory IR framing, we do want to discourage non-performative academic gaze and urge this research to be both situated in the social movements that are happening in the world, that has been happening generationally in our world, and see that social movements is an integral part of doing this kind of research. And this is something I'd really, really want to emphasize. So next, I want to quickly talk about the framework itself that we kind of proposed for emancipatory IR. So the framework has three components. It has the practices, the projects, and the provocations. The practices, I visualize this in this diagram here. So the practices is what you see on the circumference, the three practices. And then the projects are the ones that you see in these hexagons at the center. There's intentionally some empty hexagons to denote that these projects are not these are not exhaustively listed. There will be other projects, and these will be for the community to identify and decide. And last but not the least, these are the provocations for the emancipatory IR about what are the provocations that makes us think differently that has been depicted in this diagram as kind of a nudging hand. And so I want to briefly talk about what each of these kind of work might look like, kind of leaning back on some of the work that I have been doing over the last couple of years. So for diagnose and critique, this is, again, a really good example of this is to actually look at the ACM Fact Conference. They've been doing some immensely amazing amount of kind of critical work in this space. One of the work in this direction that I have been involved in was I was really glad to be part of a set of really amazing co-authors who worked on this chapter for the book Information Access in the Era of Generative AI, where we looked at the socio-technical implications of Gen AI for information access. And the main thing I just want to say is, when we talk about these, oftentimes the topics really get narrowed down to talking about fairness and bias or hallucinations. I don't even like, by the way, the term hallucination for multiple reasons, including the fact that it is anthropomorphizing. But that aside, it really gets down to some of the narrow topics. But we leave some of the really broader and important topics about how these technologies are concentrating power or how they are disrupting the information ecosystem, the questions about AI persuasion or the economic things or the industry capture. There are lots of many things that we still haven't become part of the mainstream AI and IR ethics discourse that we really need to do. And this is some of the work where we really need, especially from the IR side, people to be bridging with the ACM Fact community and working and making that connection for our community. Moving forward, the second practice is about imagining viable alternatives. So this is where I want to bring up this idea of how, and this is where some of the academic capture of from the big tech actually plays out, is that there is this notion of technological determinism, that technology is going to develop in a particular way. AI is inevitable. This current instantiation of AI will absolutely happen. So you might as well just get on board. There is no, you cannot fight a tsunami, right? And this is obviously not true for many obvious reasons, including a lot that exist in the literature. This is not the first time technological determinism has been looked at in scholarship. But this is where I think we need to fight the crisis of imagination by the fact that, like, if everybody is thinking about how to use LLM, what are all the critical ideas that we should be thinking about as IR researchers that we are not even bothering to spend time on, right? And this is, I think there is a really exciting time for us researchers in that perspective, that there is a very open space for us to do some really critical and groundbreaking work. And it's almost like there is no competition there. And so, but to do that work, I think we cannot just approach those work as IR researchers. We have to approach them as somebody who then looks at, like, other fields of scholarship and epistemologies, including feminist, queer, decolonial, anti-racist, anti-casteist, anti-ableist, and abolitionist thoughts. And I want to kind of mention a particular quote, a favorite quote of mine here from Ursula K. Le Guin, is that the exercise of imagination is dangerous to those who profit from the way things are, because it has the power to show that the way things are is not permanent, not universal, not necessary. So this is a topic that has been close to my heart, and I've been doing some work in this, including this paper on search in society. That was one of my first papers in this direction and a precursor to the emancipatory IR work as well. So last but not the least, the elaborate theories of change is then we need to think about concretely what are the projects we are going to be working on, and how do we, like, what is our theory of change? How do we think that work will have an impact on the world that we want to have, right? The right kind of impact. And this will obviously depends on the kind of projects that we are picking. So I do want to kind of, like, jump into talking about some of the projects that were represented as hexagons in the center of the visualization I showed you earlier. So some of the projects that we might care about in the emancipatory IR context, in how do we safeguard, create a public IR platform and then safeguard it against platform capture? How do we safeguard our IR platforms against surveillance and not become tools of surveillance themselves? Or how do we safeguard against AI persuasion and other forms of user manipulation? How do we safeguard against dehumanization and inequitable outcomes like fairness and bias? How do we take our IR systems and make them sites for emancipatory pedagogy to teach people of the human struggles, of the social problems that we collectively need to address? How do we visualize and mitigate the ecological and human cost, both from talking about, like, the ecological cost of data centers, but also talking about the human cost of the people doing the data labor, especially in communities like, in poor communities, economically, disadvantaged communities in Africa, in India, in South America, and so many other places. Again, very much on kind of neo-colonial lines of the global North and global South. And last but not the least, most of this work, as I emphasized in the beginning, is not, none of this is not technical, not just technological. These are all socio-technical problems and require socio-technical solutions. And so we need to approach this from a perspective of community building, movement building, and organizing within within our academic and IR community. I want to give a couple of examples what these things the concrete research questions might look like, right? So I talked about how do we make the search result page a site for emancipatory pedagogy. So I just want to give, like, one example to kind of make this a bit more concrete. So many of you might have seen this example of bias and unfairness, which is you search for the query CEO and the image search results are all men and mostly white men, right? And sure, you can go and this is a problem that is, like, an exemplary of much deeper and much more subtle biases that we absolutely should be working on. But then also we should think about, like, what if we did not go fix that particular page? And actually, instead of making the page more diverse, what if we actually gave that SERP a space to, like, feminist, queer, and anti-racist scholars, activists, and artists to create an experience that teaches people the history of erasure of different people in our society, and actually and make this a place where people learn about these struggles rather than just, like, silently inject some results that makes a page look more diverse. Like, I think actually the pedagogy is likely to have much bigger impact if you think about gender justice, women's rights, and trans rights, and what have you in these cases, racial justice, and so on. Similarly, when we talk about protecting against authoritarian capture, one of the maybe an obvious topic immediately comes up is thinking about decentralized platforms. But again, in the case of decentralized platform, we really have to think through, understand that this is not just about decentralizing the technological infrastructure, but also the social infrastructure. And I would strongly recommend this one particular podcast episode at the bottom of this slide, The Whiteness of Mastodon, that absolutely, to be honest, when I was first starting to think about decentralization, I was very naive about it because I don't have background in the social sciences. And this particular podcast episode with Dr. Jonathan Flowers really drove home the point of the challenges of moderation and decentralized governance, and how that is the part of decentralization that is the difficult part, not just the technological infrastructure. Not to say that the infrastructure is easy to do, that also has lots of incredible challenges. And then, when you're thinking about these kind of decentralized infrastructure, we also need to think about how do we safeguard against authoritarian actors blocking access to these platforms? How do we encourage epistemic justice for marginalized communities by designing the platform from the margins? How should the platform on an ongoing basis be governed and moderated in a democratic fashion? And how do we safeguard against, even if we were able to manage to create this, how do we safeguard this from then capitalist institutions or other authoritarian institutions coming and extracting value from it, or co-opting these framework without putting anything back and damaging it? So these are some of the things that we have to look at very closely, and we have to look at the history, like for example the open source movement, where and other movements where some of these similar questions have come up, and again the successes and the failures of those movements that we can learn from. And so I'm going to end by talking about where we really kind of go from there. And I really strongly believe, I hope this talk has been a bit of a conversation starter. I think the change needs to begin before we can change the technology. The change needs to happen in the community, and before that, it has to happen in us. And I'd say this not as a cliche, but it is something that has been deeply now ingrained after a few years of doing some of this work. And so we do need to think about, this is not a work just for IR people. We have to do this work with other fields humanities and social political sciences, HCI, and so on. And so we have to think about creating cross-disciplinary spaces and workshops. We have to think about reading groups and book clubs to raise our own socio-political consciousness and that of our community. We have to think about popular education, maybe even arts and zines and other things, that practices that we need to learn from movement building and bring to our own academic research. By the way, whenever I have these conversations with anybody who's kind of new to these topics but excited, I kind of eventually end up on talking about some of the books that have influenced me. So I did actually earlier this year put together a page with some of my books that have influenced me, and I'm very happy to. The link is on the slide, and I'm very happy to add if people have other recommendations. Please do reach out. I'm always looking for more things to read, and I'm still reading some of these. By the way, not all of them have I finished yet, but I did. Wanted to share this. So I will end this, and hopefully I have left a little bit of time for questions and discussions, but I'll end this on a positive quote. This really hopeful quote that I honestly I sometimes really think about and lean on it during some of the darker times when I feel a little less optimistic. This quote from the great author Arundhati Roy: "Another world is not only possible, she is on her way. On a quiet day, I can hear her breathing." But we do have to work together to open the door to let her in. So I hope this has been at least a conversation starter, and I look forward to the discussion and any questions. And thank you for having me.
Thank you very much. Questions?
Hello, Master. That was a great talk, very thought-provoking, novel, and important topics. One question I have is, obviously, it seems like, we live in a very polarized world, right? So there are people on either side of the spectrum who think others are wrong, right? So in your case, I feel like you have presented a lot of, concepts from maybe left-leaning perspective. So how do you bring more balance into your ideas and your concepts? How do you get more diverse voices, their role within your context? Thank you.
So I think this is a really, really important question. What I want to kind of bring up, and this is, I think, also a topic that I think a lot about, not just in context of tech, but also in terms of media. So I think we have to be very careful about how we talk about diversity or balance or fairness, right? So let's take a very extreme example. If, like, if you are dealing with one side that is talking about white supremacy or talking about colonization or talking about any forms of oppression, authoritarianism, what have you, you do not want to put them on an equal footing on the people who are trying to be free, right? So what the balance comes from is that when we talk about liberation or humanization, we have to apply that equally to every person. We cannot do that based on, like, just the demo, like when we talk about race or gender or caste or class or any of these dimension, it is not that just because of your skin color or your gender that you become an oppressor or you become oppressed. It's because of the history of what has happened that has created this oppressed relationship, right? And for example, if you talk about religious oppression, there will be some religions that are oppressor in some parts of the world and equally oppressed in some other parts of the world. And similar dynamics, like, you might see in other contexts as well. So I think the part about being fair and being equal and both sides, like, looking at both sides, is in terms of applying those values equally for everybody. But I do not think the role here is to take emancipatory and oppression and give them equal footing. And this is one of the things that goes really wrong in kind of in our popular media as well. And again, because of systemic reason based on who owns these media, it's like, and this is why I really don't like this terminologies of left and right, even though, again, just to make sense, I probably would identify as on the left, but I think we should really walk away from that, right? Because it's not team sport. It's not red and blue and left and right. It is about our universal humanization, about universal freedom from oppression. And those are some of the values that are absolutely are something that we have to get comfortable with. Because today what is happening is we do have values. We like to think we are apolitical, our community is apolitical. It is absolutely not. In fact, some of the values that we identify with implicitly are actually very, very problematic. So at least by making these public, like, putting this out in the open, as a community, we can then create spaces to talk about it. It is obviously not one person or a few people's job to define what they are, but we do have to push towards what are the values of, like, openness, democracy, emancipation, justice, and other things that we lift up. Otherwise, we fall into the trap of both sidism. It's not fairness, it's both sidism, and that is something we should not fall into. I hope that answers your question. But again, this is not an answer. This is really a response, and I hope this discussion continues, honestly.
Yeah, I think that's a very good answer. I mean, we all realize that, like, the values of openness and liberalness, I think all those are great qualities. But sometimes I think even in that sense we get too extreme, and you've seen how woke culture in the US became kind of went too far in some directions. So we have to also be able to control it on the other side and bring them back. But yeah.
I would actually, I mean, to be honest, I'm quite uncomfortable with that phrasing of woke culture, particularly because the term woke, if you look at it historically, has come from the practices of Black liberation against racism, and it has the derogatory use of this is humongously problematic and racist, to be honest. And I don't think I actually think that there is a notion of, like, this narrative of the woke culture has gone too far. I actually very strongly disagree with it, because in practice, what you see is that this has very, very strong, like, material and, like, life-threatening consequences for trans people in the US, in the trans people in the UK, for you seeing the effect on immigrants of being kidnapped. So I would really strongly push back on that narrative. I do think there are some other spaces where certain things absolutely we do need to hold very opposing, contrasting thoughts, where one group of people who might be oppressor in some case can equally be oppressed in the other cases, and you have to oppose all of those oppression, not just in one side or the other. But I do want to push back a little bit on that framing, because a lot of that framing has come from very, very problematic things, and it just become normalized. And this is one of the things where we do need to look at the history and understand where these ideas come from, because they're not new. we are actually having very similar conversation we've had maybe even 100 years ago. So yeah.
Thanks a lot. Just for full disclosure, I'm as left-leaning as liberal as they come. So I'm not on the right side at all. I'm actually very much like a left-leaning person myself. So just to set it correctly. All right, thank you.
Thank you.
Hey, Bhaskar, it's Mark Thompson here. I look just to sort of continue, just to be a little bit of a devil's advocate. I was looking at your definition of the IR groups meeting the ECIR track, and you were talking about it mentions about reducing human oppression. So, and again, just to make it very clear, I don't agree with these views. But for example, anti-abortion people, because their definition of human is different to yours, yes. You could end up with sort of papers being submitted to something like IR Good that somehow, that somehow that talks about a system that makes it hard to get access to abortion clinics. And they would claim that they are actually, adhering to your definition.
Yes.
So how do you, one of the reasons why I think I stay away from this topic is because it's really tricky, right? It's very, very messy and very difficult to navigate. But so, for example, to give you that example, what would you do if you got a paper that was talking about, making it hard, changing a search engine, making it hard to find a
I missed the last part of your question. What would you do? Sorry, the audio is a bit.
So as I said, the definition you had, anti-abortion people would say their views fit that definition. So what do you do about that?
Absolutely. This is actually a really brilliant question, Mark. And this is actually at the core of why I think this is difficult, right? So, and one of the things that I want to be very clear, if this hasn't come through in the talk, is I don't think the platform itself, or as researchers, it is not for us to enforce our belief of what is emancipatory on the world. And this is where the emancipatory framing should be looking at things from a structural perspective, right? And this is where I was also, again, sorry, I didn't have enough time to kind of go deep into it, where when I was reading Paulo Freire's Pedagogy of the Oppressed a few years ago, it was literally one of the most influential book in my life, because it actually gets to this point, right? It is not somebody's job to come and decides what is right and wrong and then say, oh, I'm going to liberate all of you people. But it is about creating the condition where people can have that discourse and come, figure out what is it that they want from themselves. And so when we are thinking about IR platforms, what I am trying to kind of point towards is that the IR platform itself should create that space for that social negotiation, that conversion, for that pedagogical spaces. And in doing so, but doing that in a way where, again, we have to think about scholarship, right? So this problem, to be honest, is not that different. It's in some ways, there are some differences for sure in how we think about scholarship, right? So how do we deal with, in our academic scholarship? People have different ideas, people believe in different things, but while we have these conversations in a structured way where they have to look at previous scholarship, they have to reference it, they have to build on what has been established before. Our scholarship, we often forget our scholarship, our IR or CS or tech work is not just about statistical significance tests. It is a social process of consensus building. And so now the question is, just like in academia, we think about how do we have a process for consensus building that actually takes us towards the true science. We need to think about how we do that similar kind of process where it is for people to negotiate those on the ground. And over time, we actually are dismantling systems of oppression, right? So it is not about putting an anti-vaxxer and a person who's pro-vaccine on equal footing, but putting those conversations in a way where they could be grounded in scientific discourse, talking about abortion, whatever the scholarship that exists, whether from medical science, social science, the lived experiences of people who've had abortion and people who have had abortion and regretted it, all of that. We need to create that space to have those messy conversations, but it is important that we leave that space, because if our platforms get captured, basically that is what gets wiped out. Like, with the executive order and things where they say, no, you have to, all your platforms will have to present only a particular perspective. So that I absolutely agree. Like the abortion case, I do not take it as a black and white issue at all. And especially as a man, I don't think I should have any say unless I am somebody who's capable of giving birth to a child. It is not my body. It is not my conversation to have at all. So.
Thank you.
Thank you.
I don't have a question. So I'd like to thank Oscar for this wonderful talk. So it actually, I mean, rather than closes some issues, rather opens up a lot of issues to ponder over. Because in my opinion, it's not whether the left is right or right should be left out. So it's a multi-dimensional world with multi-directional ways.
I actually could not hear the question. I'm super sorry. It's really breaking up. I'm really sorry. Could you repeat?
Honestly, I don't have a question here. Okay. I don't have a question because it, I mean, rather than it raises some questions that does have immediate answer. So it opens up many more questions that we have to find answer in the days to come. So I'd like to thank for this provocative talk. And because of time, I mean, I would like to kind of call. Right. I mean, I'd like to. I mean, thank you and thank our chair, Liam. So would like to offer you a memento that will be sent. I mean, through post. So again, I mean, thanks for spending your time here and enlightening. So thank you.
Thank you.
Thank you so much for having me. And again, apologize for not being able to be there in person, but thank you so much.
So I think that we can close the session. Thank you very much for the time. Thank you very much for the talk. So it's a tea break for 15 minutes. Maybe we can gather here after post tea break. We can gather at 10:50. That would be fine.
Hello. Ganesh, we are audible? Ganesh?
Yeah, it's
You are
audible.
not- Okay, okay. So I am going to start my presentation in 2 minutes. So it will take around 5 minutes and after that we share your screen. Okay?
Yeah, okay.
So welcome back. I'm going to start my track presentation, which SQCA area, spoken and documented inclusion. So I'm starting with the overview and after that, maybe one participant presentation. So my name is Bhargav Dave. I'm from DICT, DICT formerly known as DICT Kaminagar. So my track name is Spoken Query Cross-Lingual Information Retrieval for Indian Languages. So basically, in India, we have a problem like many people not able to write properly or not able to search properly. So we propose a track where people can speak the Indian language and able to retrieve from the different Indian language documents. Like take a case, if I speak in Gujarati and document is in Hindi, so people are able to retrieve Hindi document from the using the Gujarati method. So myself, President Madhudar, Devasis Ganguly, and evangelist running this track. So this is my overview, introduction, track timeline, participant, task to and data set. And after that, I will hand over to my only one participant who submitted a run. So he will explain this method and result. So as I explained, people will speak in any Indian language, currently without internet for Indian language, and do the search happen on Indian language document and give us the top 3 document. That is the task over. So this is the track timeline. Like website started on 5th June and ended all the thing by 30 September. We ended all the thing by 30 September. We got 16 registration, but finally we ended up with only one participant submission. So I think our data set is very huge. And because of that, I think many people are not able to run the evaluation on spoken query retrieval. So one run sufficient and one working on in this track. So task detail, first task is spoken query ad hoc retrieval, monolingual task. So in monolingual, we have same language, query and passage in same language, like Hindi query and Hindi passage. So this time we have a Hindi, Gujarati, Kannada, and Bengali in task 1. Task 2 was cross-lingual, where we have a Hindi, Bengali, Gujarati, Kannada query, and same way Hindi, Bengali, Gujarati, Kannada documents. So data set we used Indic MS Marco which is translated version of the MS Marco. So it have around 11 language, Indic language. So from there we gave only 5 language, which I said. Also we prepared a spoken query data, SQCLIR. That is contribution of this task. We prepared 97 spoken query from different people like male and female. So we around we have 5 male speaker in each language and 5 female speaker in each language. So total 97 query with multiple instances. So now I am handing over to my participant. He will continue from summary of my.
Yeah, I will share my screen.
Yes, I am stopping screen. Wait a minute. Okay. Yeah. Go ahead. Are you able to? Your screen is visible.
Is it visible?
Yes, visible.
Yeah. I think you would have got some idea about what the task is about. For this task, we have used 2 models. One is BM25, a baseline model, and a transformer-based model in the BERT. In this, I will give a brief methodology overview. First, from the given audio queries and text queries. If it is an audio query, we have used a Whisper ASR model to transcribe into text queries and have done some pre-processing techniques such as removal of stop words and lowercase letters for better result. And the 2 models are first one is a BM25. BM25 is a baseline model and it uses term frequency and inverse term document frequency, that is the TF-IDF, which we all would know. And the IndicBERT is in the IndicBERT model, we get a dense embedding, which is of 786 vector length. It is very large to store, and since the data set is very huge, it required a very large amount of GPU to process it. And we have stored the IndicBERT embeddings in FIAS index, and we use with the help of vector database FIAS, we have retrieved the similar documents with the help of TOPK. And in evaluation setup, we have calculated the NTCG, MRR, and the recall at 10, 100, and 1000. So in data set structure, we have given spoken queries. We have selected the Hindi language first of all. And in spoken queries, there are both male and female queries are given. And also the corresponding text queries also given by the organizers. And additionally, we have also recorded our own queries. With the help of my friend, I have also recorded the all 97 queries, only the male voice, and we also have tested it on the model. So we can observe that these are the results given by the BM25 model, and these are the results given by IndicBERT. From this, we can clearly observe that BM25 has a better performance than the IndicBERT model. And within the model, text queries perform high because text queries does not have any errors, ASR, transcription errors, or anything. So given text query has a high value. And from spoken queries, compared to male and female, female have higher result. This is because due to female voices have lower transcription errors compared to male voices. So it would have get higher value. And BM25 is based on keyword matching, so it would get a higher result. And in the part, we have just used the pre-trained model, and due to a time constraint, we cannot pre-train the model. Sorry, we cannot fine-tune the model. We have just used the pre-trained model, so that only problem is fine-tuning is not done, so that the results are somewhat less compared to the BM25. So task-specific fine-tuning should be done to get higher results. So from this given data set, BM25 clearly outperformed the IndicBERT. So BM25 outperforms IndicBERT, and text queries perform better due to less ASR errors. And due to the vocal performance, female queries are better. And IndicBud suffers more due to ASR noise because we have not done any fine tuning. We will in future work we will definitely work on the fine tuning process. And in conclusion, we can say that BM25 is most reliable for the given data set, and mainly the ASR noise remains the largest factor. Due to the ASR noise, the results definitely gets affected. The ASR noise plays a major role in designing the result. So lesser the ASR noise, higher the results will be. Yeah, thank you.
Okay, so any question? I think no question. So one more update that we also our paper published in the journal that is called SQCLIR, Spoken Query Information Retrieval for Indian Language. You can search on Google or on PR later it's published, so you can check it once. Okay, so my only one presentation completed. Now I am only handing over to the Promet track. Only overview will happen now, and the presentation, participant presentation will happen in the evening after around 4. Okay. So handing over to the thank you very much.
Hello everyone. So this is on for as well, and basically I would like to thank your medical team lecturers, especially for accepting our shared task from recovery for misinformation detection. So this is our first subtask. This how we will be talking about today, and this is like the overview. So how we will quick. So given the current pace of large language models, it becomes a part of our daily life, and you can either following either be used by users in their daily life as an assistant and generating summaries and also so many other tasks. Of course, the common one is the search box, and we see that LLM have this hallucination, which is not basically a prompt or like a response dependent aspect, but it is also a structural property of LLM, common bug. So we are actually open this shared task basically to tackle the systematic benchmarks and detection methods that are lacking in the high stake and large stake task. So yeah, our task basically comprises 3 distinct subtasks. So this first task is basically on reverse engineering the prompts from machine generated or LLM generated misinformation text. So for the first subtask, we participate piece of LLM generated text with misinformation, and so there will be a summary in the title. There will be a prompt. So the prompt actually it has to be basically reversed. So basically that will be actually HR. And this, so we also have this, so all we can only train and test sets of this subclass later on the slide. The second class is focusing on basically identifying this information, seeing the text. And the objective is basically to categorize it into different categories. Basically finding most effective categories in each generated summary. The third subtask is basically focused on the social media space. So we are identifying this information from data, basically focused on the first year of this so Ukrainian conflict. So we have this mainly inherited data from this conflict focused on the threats basically. So the first task is basically, as I said, that we are providing a user that basically participates in use summary. The output will be misleading, basically that will be transformed into a misleading headline. And we want the participants to basically decode that prompt that actually produces misinformation or fabricated text in the basically this misleading headline. And the task is basically to focus on like what's the robust method we can develop. So we are given this the user, and our dataset contains around like 10,000 templates of this summary, headline, and prompt. And in the test set, we only give summary and headline. We want the user to recover basically identify the actual prompt that led to this misinformative text in the headline. And we generate this 10,000 sample using GPT-5. So the steps we follow is for the data is based on these 4 categories. The first one is public user that requires class and then iteration. And we try to say we have this 2 categories per summary just to keep the data balanced. And we also have this predefined template to generate this prompt user. I think this was visible. So yeah, so the resulting prompt, I think as we have from the predefined templates, it also in lexical, it preserves the lexical variation and semantic property. We use that to generate. We basically have this use that prompt to generate the headline that actually indicates and contains format text. So the step 1 is this is one example. I think the real realistic example from our research. So this says like so this is basically the green text that I will read now. So common when captain answer the same predictions to draws retirement. Owner influence gives investment to retire. So and then investment terms 41 UVD as his test. So the what we detected is that it's the names and of course this numbers basically the quantities are like 41, 50. So these are like we found that is misinformation, and these are basically medium categories. So you can see that there are 2 categories. Actually, some reasons are we selected this category. There are like 4 categories, but this is just an example. So we are showing that like each of the text actually have at least 2 categories, up to 2 categories basically. And this is the assigned prompt you can see, and the lexical variation and the generation of like what we want to do for the semantics is we have to use the plan prompt. And this is the final headline. You can see the very last line, whether the name start traces the data questions up here. SSCD. So you can see that this is a misleading and for the evaluation of this first task, we focused on this word score and this F1 score based on one metric. This cosine metric. So these are the 3 key metrics that participants can be given to evaluate. And interestingly, this task seems to be difficult overall. And we wanted to submitted over 5%. Most of the submissions were incorrect, so there were not actual prompts. So from this stuff, we find it challenging at this even the like benchmark results for the participant. The second step is on misinformation. So in the generated Carolyn summary for the name. So we want to identify what actually correct news articles or not. So we actually organize into this 4 predefined categories, and this second task is actually based on the previously Indian language summarization task of 2023 and 2024. The new languages were added in this task is on Canada, Tamil, Telugu, and Malayalam. These are the 4 categories which we are proposing to basically categorize in misinformation and airline summaries. So the first is the list of the This involves like twisting the fact, narrative. The second one is of course giving accurate measurements of the quantities. Third is like the false attribution, basically creating to some loss, so that that is the third category is fabrication, which is of course the underlying category that we have. The data set is actually collected from by generating by using GPT-4, and we have these two categories. You can see the quantities and which is this. So these were actually collected to identify which were worthy interactions, like the potential interactions. And we have the examples of this numerical quantity. So these are actually, so these four categories are kind of inputting back the data. So we have these four categories based on that. And then data side basically that we can generate this potential. So this is focused on the high profile. So you can see one of these multiple years and of course some very high profile like very focused entities like some wars. And the data set contains 5,000 training samples with 200 test samples. So you can see yes, so we have this underlying from sample from the Indian language summarization. This is distribution you'll see. Okay, the units we have is like one more category, so that is like if it is correct. So that would be like overall 5, factual correctness. And we use macro response as the important part to a very possible. And we receive like 22 euros and receiving 3 services for the working notes in this subtask. The best one is it's Palestinian GRE based, and of course this transformer plus Palestinian kind of method for, and this is the I think best result from all of this submitted working notes, and the follow on this that's I think the details of on the participants will be presented in the second half and probably everything. These are the results from the participants. So you can see the precision of this so yes, it is still not very good in terms of, so we can see that this task like crossing over some rates low risk language focused on camera Telugu and Malayalam. There's a continuously research on basically relating misinformation that government articles. And it tasks us it actually focused on the Twitter data. So this actually has the manually annotated grids of the first year of this Russian conflict. And we the questions asked to do this specific task of information that not this. So this is using the underlying data image from the website, which is published the website conference, and we are using that. You can see that the data contains 31,174 conditions. This information creation and basically for information creation data. Training set that's that is you can see it's only 3,000 models information person. So currently we see many solutions in this slide. We had overall 9 participants submitted the working notes with 27 participants, and then this was set up on this reproducible leaderboard image. So we had this public runs. So overall, we had 3 runs out of these from these 7 teams, and these are the leaderboard result of these 9 participants. 7 submitted as the working notes, and we can see that the best performance is 91 even in this very high scale. So, and this is the reference to that data. So we can see that this misinformation in this evening of LLM is still an ongoing topic which requires for speculative report from the committee. And I would like to thank you again to all for organizing the members who led this piece of task. Thank you.
Can you hear me? So next, we have a cross-level mathematics information retrieval track. So I'm heading over to the IOC.
Good morning to one and all present here. My name is Ayushi Malik. I'm a full-time PhD scholar at School of Computer Science UPS. And today I'm here to present overview of cross-lingual mathematical information retrieval shared task overview. And this shared task was jointly organized by me, Dr. Pankaj Kundan Ladri, and Dr. Tanam Rahman Datkar. So first, I would like to start with what do you mean by information retrieval? So information retrieval is a application of natural language processing which is used to retrieve useful information from large pool of data based on user queries. And like we have the available search engines like Google, Bing, Yahoo, they are very good for plain text. But when it comes to mathematical text, we have mathematical information retrieval, which is a subfield of information retrieval and which is used to retrieve mathematical formulas, queries based on user entered queries. But currently, math search engines are functioning on English language. So they are not available for any low resource language like Hindi. So our shared task focuses on low resource language like English and Hindi. So cross-lingual mathematical information retrieval is a subdomain of mathematical information retrieval, which is used to retrieve the mathematical information across different languages. So we have organized the first edition of the shared task on cross-lingual mathematical information retrieval at 17th Forum of Information Retrieval and Evaluation. The cross-lingual shared task focuses on enhancing the research in cross-lingual mathematical information domain across English and Hindi. The primary objective of this task was to promote the research in this domain and create a benchmark dataset for English Hindi and enabling a fair comparison of retrieval models. So a total of 9 teams participated across various reputed institutes like Archita Dhyani from UPS, CJM from ISR Kolkata, TENS from NIT Kurukshetra, ILL from IIT BHU, J22 from IISR Kolkata, NLP Fusion from Bangalore University, Math QAUS from Assam University, DUCS KMIR from University of Delhi, and Retriever from the Dhirubhai Ambani University. And out of these 9 teams, only 6 teams successfully submitted the results. And for the data preparation, we have taken the publicly available data set, which was ARQ, and then the pre-processing was done. Then we have done the human validation to check the consistency of the data, and for data standardization, we have released it as a part of. So for data processing, unnecessary tags and extra content that was not useful was removed, and all the text was converted into lowercase for better retrieval accuracy, and hyperlinks were also deleted from the data. So these are the data statistics. We have 39,862 instances in our dataset, and there are 11,119 instances in our judge file, and we have given 50 test queries. So this is the overview of our dataset, which contains ID, title, body, and tags. These are the results and observation of a shared task. Retriever achieved the highest map and NDCG. IRL showed major gains with map 0.1650 and NDC 0.3063. Aditya Dhyani probe steadily probe the ducts. Retriever and RL led in the precision at 10. These are the differences. Thank you.
I have a question. Can you go to the data set now?
Statistics.
Yes. So from where you took this data?
I have already mentioned that I have taken this data from publicly available dataset AR3.
So here, what do you mean by training data?
What?
What do you mean by training data?
Which is used to train the models.
So only passage or query is also.
Sorry.
Training data means document or query. How many
Queries, which contains the text in English and the LaTeX formula.
Okay, so training data also contain query and passage code.
Actually, the share task force organized by 3 people. So.
Okay.
So next, I will like to invite Ritik Kumari for the next presentation.
You have only 5 minutes. So directly go to the manual.
Good morning, everyone. I'm presenting our work of title for single mathematical information retrieval. This work is done under the guidance of Dr. Sukumal Bhaskar. No, this work is done under the guidance of Dr. Sukumal Bhaskar, Dr. Supriya Chandra sir, and Krishna Devarmana. This work focuses on retrieving documents that contain the natural language text and mathematical expression across multiple languages. Let me move to the directly as data set and task description is already shared. Our approach combines semantic text similarity and mathematical similarity. We have used a sentence transformer model, specifically multi-QA mean item L6 cos V1 for text embedding, SymPy to parse and compute mathematical expression. We have computed a hybrid similarity score where 70% weightage is given to text similarity and 30% weightage is given to mathematical similarity. To ensure scalability and efficiency, we have used PAS index IDF, parallel processing with multiprocessing. Moving towards the method. Our methodology consists of 4 major steps. First, we have generated embeddings using word-based multilingual case applied to only combined text field. And secondly, mathematical expressions are parsed using SymPy, where expressions are converted into symbolical form. Third, we have built PAS, IDF flat index with 100 clusters. Finally, for each query, PAS produces top 500 documents, compute the hybrid similarity score, perform retrieval in parallel to reduce latency. Moving to model architecture. This slide shows the overall model architecture. The input consists of training data with nearly 40,000 instances and 50 test queries. The text embedding module uses mean-lm to generate embeddings efficiently. In parallel, the map similarity is computed separately using SymPy. The embeddings are normalized and indexed using FAS for fast retrieval.
And in the retrieval module, FAS returns top 500 documents based on text similarity. Mathematical similarity is computed separately. Both scores are combined using a weighted formula. The entire pipeline is parallelized using multiprocessing, making it scalable and efficient. The output consists a run document for each query. The final output file contains 2500 rows corresponding 50 queries to 50 retrieved document each. Each query includes a query ID, retrieved document ID, similarity score. Our system has successfully achieved accurate detection of mathematical equivalent expressions, efficient retrieval using FAS, robust handling of Hindi, English, and mathematical content. This table shows the official evaluation result organized by 525 organizer. Our team achieved precision at 10, 0.11122, MEP at 0.1650, and NDGC at is equal to 0.3063. These results demonstrate that our hybrid approach performed competitively among all participating teams and significantly outperforms the organizer's baseline. To conclude, we successfully built a cross-lingual mathematical information retrieval system that handles multilingual text, accurately matches mathematical similarities and expressions, but scales efficiently using FAS and parallel processing. Our approach effectively addresses key challenges across multilingual math retrieval. For future work, we plan to explore MathBot and other math-specific modules for better embedding and extend our system to additional languages, including German, French. Our approach, thank you so much. Any questions? So I would like to call next participant Venkatesh Shuklas. पाठ पटेल and Nishit का चालू है
Good morning, everyone. We have solved this task using BM25 and LLM based point-wise rewriting technique by me, Kishore, and my teammate Parker from BM. Further statement is mentioned by track organization. Then data set is given by Threat Organizer over 39,862 documents and 50 test query in English and query format is given by English context and math formula or in latex format. And then, first of all, the preprocessor query where we concat query text and math formula, and then we translate the English query into using the code which given this translation code where we only translate the language words and keep them the mathematical formulas and latex format. Then we propose, then we do three strategy for solving this task where first we do BM25 as a lexical approach for the retrieve the documents of top 50 and then in second strategy we retrieve first of 100 document using the BM25 then re-rank these documents using JAMA 3-4 billion models and retrieve of 50 documents. And in strategy where we use the JAMA 3-12 billion models instead of JAMA 3-4 billion models. And for the re-ranking, we use this prompt for Hindi prompt for that. And this is our evaluation results where you can see that hybrid pipelines are significantly improves retrieval accuracy from for the BM25 where our BM25 plus JAMA 3-12 billion models gives a high accuracy and it's across the all evaluation matrices and we have achieved top one rank in this task.
Yes. Validation.
Greetings to everyone. I'm Venkatesh and I'll be presenting my approach upon the shared task across language mathematical information retrieval. So I would like to move towards the methodology. So before arriving at our final design, we evaluated several possible systems. One option was to use multilingual embeddings that project Hindi and English text in a shared vector space. While this idea was attractive, such models tend to emphasize both semantic similarity and are not optimized for mathematical symbols or fine-grained token level matching. The other idea was to translate the English queries into the Hindi queries. This approach had the issue of introducing latency and increasing the risk of compounding translation errors, especially for short formula-heavy query. We therefore adopted a translation first, retrieval second strategy by translating the entire Hindi corpus into English in an offline setup and convert the task into a monolingual retrieval program. This allowed us to use and leverage mature English model while maintaining consistency between queries and documents. The design choice simplified our architecture with robustness. So now we move into our information retrieval pipeline. The first step was document representation and reprocessing. And the document consisted of three parts: title, body, and tags. Rather than treating all these relevant signals independently, we merged them into a single textual representation. By integrating all the components, we allowed the retrieval model to consider contextual, semantic, and domain-specific use simultaneously. The next step is the translation of the dataset documents. The translation is the foundational component for our system. We use IndicTrans2, a transformer-based translation model specifically trained on Indian languages. The choice was motivated by the empirical observation and general purpose translation model often struggle with Hindi technical text, particularly in mathematical contexts. This step effectively created a unified English mathematical corpus for us. Now, this was the most important step. We choose to convert V2 as a dense retrieval model due to its late interaction architecture. Traditional sentence embedding models compress an entire document into a single vector. While efficient, this approach disregards immediate structure, which is critical for mathematical text. Colbert V2 in contrast encodes documents in queries at token level, computes relevance through fine-grained token interaction, preserves partial matching between symbols, variables, and technical terms. This is particularly important for the mathematical retrieval task. So the token level embedding significantly increases our computational cost. So to address this, we use PIS for approximate nearest neighbor search. PIS allows us to retrieve the top 100 candidate documents efficiently while maintaining high recall. This ensures the system remains practical for large corpus. While dense retrieval is efficient for candidate generation, it cannot fully capture deeper semantic relations. We therefore introduce a cross-encoder re-ranking stage using mini LLM L622 model. The cross-encoder jointly encodes each query document pair, allowing it to model detailed semantic interaction that dense retrieval may miss. So now this was our evaluation. Now there were three evaluation matrices: precision 10, mean average precision, and normalized discounted cumulative gain. Now our scores do not seem great, but they could have been much better. The issue that arose was there were four dataset files and you missed one of them. So the score that you are seeing is basically out of a corpus of just 30,000 data packs, rather we had to use 40,000. So we also compared our model against other architectures like Colbert V2 without re-ranking, Colbert V2 is cross-encoder re-ranking, and Matplotlib-based retrieval. All these models performed less in comparison to this model. So hence we moved ahead with Colbert V2 plus cross-encoder. So our limitations. So even though this architecture is quite robust in its nature, it's still quite simplistic. The mathematical expressions are treated as plain text in this. No explicit modeling for latent structure is provided by us. So for our future works, we will try to incorporate latex aware mathematical retrieval techniques. We will use dual space retrieval for text and formulas separately so that we can not only do semantic search but also symbolic search in the dataset.
So at the end, I would like to thank the organizing committee.
So thank you. Next, we have a presentation from Simon.
Hello. Good morning, everyone. Myself, Dr. Gulgari Man from Jadavpur University. I'm here to present our red overview paper, one side height, that means research highlight generation from scientific papers. So these are the contents of today's presentation. First, I would like to discuss about the interactions, then the problem statement details, then data set we have provided for the satellite track, and the team's performance and the team models and results, and then conclusion at the end. So here they use information everywhere. So what we need a less information so that we can go through it quickly. So in our problem in SciHi, we have taken the scientific paper because there's a huge growth of scientific publication makes it very difficult for researchers to keep track of new research even in a narrow software. So nowadays, many publishers are asking the full paper as well as the abstract along with the bulleted point of research highlights, authoritative research highlights. So that our research highlights are written in a very compact way. It reflects the main theme of the paper so that readers can go through it very quickly and also that it is very useful in our handheld mobile devices. So why we need the automatic highlight generations? Because when we are talking about these terms, then there are some important questions comes in our mind. What kind of summary does people want? And how we can measure the summarization's quality? So there is basically two types of summarization. One is extractive and abstractive type of summarization. Extractive means what? We just crop some phrases or we can take some sentences directly from the input documents. But in case of abstract nature, we have to go through and read the whole documents properly, and then we can take a small or some just form of summary from that paper. And how we measure the summarization quality? There are some automatic methods like the RAG matrix, methods, and others metrics. But in case of abstract, the summarization quality of the measure this is a little bit of different because we cannot compare the word directly word and word in the next expression. So in highlight generation, is this abstract type of summarization or it is extractive? So from this example, you can see this is the abstract, that means this is the input, and we are intending to generate the summary like a author written research highlights in a bulleted pointer format. So here you can see the some points of the summary that is not directly taken from the abstract in a full sentence wise. So this is the abstractive in nature of summarization. So for the SciHi track overview, our main task is to generate the high quality of highlights from the abstract. So what is the input here? Input we are giving the scientific paper abstract. And output is what is 3 to 5 bullet points of highlights. For this task, we have using the mix of data set. It contains 19,785 scientific papers from the Science Direct 2020 published papers. The papers in multiple taken from the multiple domain of corpus like biological, chemistry, energy, and management and social sciences, etc. So from this figure, you can see this is the statistical distribution of paper in mixer data set in test field. The similar pattern we have the distribution in case of trade as well as the test subject. So here you can see the speed out of 15,000 instances, we have chosen only that 10,000 for our training and 1,985 instances for our dev, and the test is 1,840 instances. So in this slide, I will highlight the team details. Initially, we had the 14 team registration, but later we have seen the 12 teams submitted their runs. And we have taken only the 2 runs for each of the team. And after that, we have seen that 10 teams have submitted their working notes in report format. So here you can see there the team name as well as their affiliations. So we had the multiple teams across the different state of India and from as well as the central university and many NITs and private university as well as the public universities also. And here this is the result for each team wise. Yeah, so the next highlights energy team to the first rank, and we have ranked all the team based on the Rakel matrix. And we can see that the model ages and trends, we have analyzed that from the team, all the team, T5 variants chooses the 8 times, and as with the BART variants chosen by the 5 teams. Similarly, Pegasus variants chosen by the 5 teams, and the LED and long format chosen by the 2 teams. Similarly, the LLM like of Llama 2 chosen by the 1 team, and BART variants, district button sidebar chosen by the 2 teams, and some like of traditional ML, like of extractive methods chosen by the 1 team. So this is the model ages and trends by our teams in our SciHack. So in the next slide, I would like to request our one co-organizers, he is present here, Dr. Lushik Masana sir, to explain the target.
Thank you, Lavina, for the interesting talk. So, this care track was a great success, I think, because it is the first time we are organizing and we got submissions from all across the country. There were around 12 submissions, as you have seen, and many of them submitted multiple runs. And we found that they have used a wide variety of approaches. So from there, we find that the transformer models have achieved the best performance. So there have been more simpler models also, but they naturally could not match the performance of transformers. But interestingly, we did not find the use of large LLMs here, like Gemini or large Llama 70 billion model or such large models were relatively uncommon. Like there was only one submission that used Llama, also smaller variant. But still, the raw scores were more or less okay, but they were not still very high, like around 23, the highest one. So there is a scope for improvement. More importantly, we are thinking of several directions to extend this work in future. For example, we can have better evaluation matrix. Right now, we are using the raw score, but the output being abstractive in nature, probably this unigram or n-gram based overlap may not be the best way to solve it. We need to check the semantic similarity between the predicted output and the ground truth. Then the data set, as she has mentioned, is multidisciplinary in nature. But here, the whole data set is treated uniformly by the different participants. So I think there is a scope to consider this multidisciplinary nature of the data set to improve the models. Then different other related tasks can be formulated here. For example, yesterday we had a wonderful talk by Jack on simplification of scientific texts. So this is related to it, very much related. So we can think of these highlights as some form of simplification of the paper. Not only summarization, but also simplification. So maybe we can try to make it more suitable for different grades of users. For example, the expert user who understands the topic, the technical nuances will require a different level of presentation compared to one who is not so much acquainted with the technical vocabulary, with the technical details. And finally, the most important thing, we need to explore smaller and greener models. So Professor Majumdar is here, who the pioneer in this field is trying to build up this green AI movement. So we are also of the opinion that we need green models so that we don't depend on these large models for specific tasks like this. Large models may be more generic, but for specific tasks, maybe smaller, greener models are more effective. And I would also like to thank our third organizer who is not present here. He happens to be my supervisor and our supervisor as well, Professor Somilam Chattopadhyay. He is an ex-professor of Jadavpur University and now the Vice Chancellor of India University. He also always tells me that go for smaller models, not large models, smaller models which are more suitable for your task, because ultimately if we end up consuming a lot of electricity and destroying nature, then what's the point of having an AI system if humanity is destroyed? So we need to keep all these multiple directions in focus to develop better models. Thank you very much. I think the individual teams will give their presentations. Thank you. student of the mind. So I was wondering, in your data set is 2020. Yes. I would like to know the specific reason for it. And one more is, I don't see your distribution of the data set, humanities and social sciences. The domain. I haven't seen. And the last question is like, can we think of Indian languages journals in this direction? The distribution. The first question is why basic ranking. Actually, it's more related to her PhD. She started doing her PhD around that time. So at that time, the data set was prepared for early results from that time. And obviously, we can augment the data set. Size will increase if we collect the later papers. But I think fundamentally, it will not change the data set. Okay. So more papers can be added. And regarding the distribution, can you please go back to the humanities put here? No, it's not visible. Yeah. See, when it comes to Indian languages, we don't this person again. We have science direct, Scopus, web of science in English only. But what happens in the case of Indian language? Don't we have Indian languages, online journals in Indian language? If there are some couple of, suppose I speak Telugu, there are a couple of online journals in Telugu. So can we think of such kind of metric to extend to Indian language? That's what strikes to my mind. Yes, that's a very good question. Thank you for that. Now the question is, how do we get high quality journals in Indian languages? I remember several discussions where, scholars are not always agree that the journals which are there are of very high quality. So we compare to the publication by Elsevier or Spectre, like that. So yes, if we have a good data set, we can build a good data set of high quality. That's definitely we can include, and we should do that. Okay. So another direction which we are exploring is whether we can convert the abstracts to the Indian language. Okay, so that is another direction in which we are working. If we can do that, probably that is another way to extend the data set. And we have social science actually in the last section, very small. This was initial distribution. Obviously, this can be improved because there is a certain imbalance in the data set. So obviously, there is scope for improvement. Thank you very much.
Hello, Sangita is here for paper ID 25. Hello, Sangita. Have you joined?
Hello,
Yes.
I am audible to you.
Yes, you are audible.
Yeah, sure. Now I am sharing my screen.
Yeah. Your PPT is not visible.
Yeah, wait, ma'am.
Yes. Okay, Shanita, you can start.
Good afternoon, everyone. I am Sangeeta Singh, a research scholar from Computer Science and Engineering Department at NIT Patna. Today, I am going to present my work titled Automatic Scientific Headlight Generation with Transformer Models, carried out by Sangeeta Singh and Navya Singh and Jyoti Prakash Singh. Now, this presentation is organized into 5 parts: introduction, dataset, description, methodology, results, and conclusion. Now, let's start with the introduction. Scientific publications are growing rapidly, making it increasingly difficult for researchers to quickly identifying the key contribution of a paper. Scientific highlight generation aims to automatically generate short and concise highlights that capture the most important points of our scientific articles. So it is more challenging than journal summarization due to a long document and domain-specific languages and limited annotated data. So this work investigated transformer models to address these challenges. Now we have used a mixed science hub data set designed for a scientific highlight generations. It contains 10,000 training samples and 1,985 validation samples. And for the testing purpose, 1,840 samples for a testing purpose. So our proposed approach is based on a transformer encoder decoder architecture. This model takes a scientific abstract as an input and generates highlights as an output. So we use Microsoft token prediction and sequence to sequence learning to train the model efficiently. So we experimented with multiple transformer models, T5 small, T5 long, T5, and the Pegasus model. So these transformer model have a different architecture, which is shown in this slide. Now we also used Pegasus summarization specific transformer model. Its key features is a gap sentence generalization with where important sentences are removed and expedited during the training. So all models are trained using these parameters: optimization, Adam optimization, learning rate, batch size, epochs, beam search, and maximum input length, maximum output length, and weight decay. Now we got the result. Now we evaluate our models during ROG and micro matrices. Pegasus consistently achieved the best performance across ROG1, ROG2, and ROG-L on both validation and test data. So based on ROG-L, scores, our team text highlights gen achieved rank 1 among all participating teams. So now in the conclusion, we successfully generated scientific highlights using a transformer-based models. Among all models, Pegasus achieved the best performance. Our team ranked first in the shared task, demonstrating the effectiveness of the summarization scientific pertaining. So thank you for your attention. I will be happy to answer every questions.
Any questions from the audience, please? Please give a big hand this highlight. Our next is the Harsh Mishra, paper ID 7.
Yes, ma'am.
Okay. You will speak first. Can you please start from the methodology section?
Ma'am, my screen is visible.
Yes, your screen is visible. Can you please start from the methodology sections of the paper?
Okay. So, respected session chairs, honorable judges, and my fellow participants, good afternoon. Myself, Harsh. Today I am presenting research title Hybrid Transformer Based Summarization for Scientific Highlight Generation using the mix of Sci-Hi dataset. So this is our methodology. So we use two models. One is hybrid extractive and abstractive pipelines, and second model is distilled extractive baseline. So first we pre-process the data, and we paired the abstract and highlights, and in run one we use hybrid abstractive pipeline, in which we extract scoring on base of TF IDF plus BERT, and then we use redundancy removal and after abstractive rewriting by using BERT large model. Like in second run two, we use distilled extractive baseline, and based on this we calculate on evaluation metrics rough1, rough2, rough L and meteors. This is the performance evaluation on Sci-Hi 2025 dataset. This is the analysis of trade-off. This is a metric comparison between models, distribution of error type in generated highlights. So error analysis, hybrid BERT model errors, it overgeneralize of domain specific technology, minor redundancy despite MMR filtering during extraction phase, occasional generation of pollusive but factually inconsistent phrases. Here same distilled baseline error cause sentence fragmentation leading to incomplete ideas, loss of contextual continuity between selected sentence, abrupt topic shift, redundancy, overall coherence, inability to paraphrase or simplify complex expressions. These fragmentation and context loss primarily affect the extractive model, while overgeneralization represent the main challenges for the abstractive component. So this is the future research direction: actual consistency checking, long document handling, human evaluation studies, domain adaptation, and system integration. So technical challenges we face like managing token limitations when pre-processing lengthy scientific text, balancing fluency and technical precision in domain-specific language, effective redundancy removal in abstractive generalization. Some deployment insights like hybrid models show strong promise for real-world application, lightweight extractive models with low resource environments, and combination of automatic metrics with human judgment essential for validation. So thank you. We secured second rank in this. If you have any doubt, please ask regarding this.
Please give a big hand to the next speaker is Sivalonko Shahu. Paper ID is 31. Open presentation.
Good morning to all. Myself Shivasukar Rao, presenting our transformer-based models for research highlight generation from scientific. So these are the presentation outline, and scientific publication have witnessed a immense growth in the last decade, around 60% increase in the per decade.
Abstracts are full long and it is very to get the information from the abstract. So writing highlight is a very difficult task. So we try to build a automatic highlighted system that offers a fast, clear, and scalable solution. These are the some existing works that is paper published in this area, and most of the works are regulated in the documented. And these are the statistics of the data sets in the this data. And we explored the following models: BART, T5, long T5, lead, and Pegasus. And we experimented with several kind of hyperparameters. And these are the following hyperparameters. The models provide the best performance. And these are the scores: Rogan, Roktu, Rogel, and Meadows scores. And among the different kind of models, BART provide the best performance in the different kind of Rogan, Roktu, and Rogel score. And Pegasus provides the minimum performance. There is no significant difference between the T5 and long T5 because although sentence length is more, but it is not affected in this. These are the some highlights generated by the author written and the written generated by the our models. And these are the graphical representations of different evaluation score: Rogan, Roktu, Rogel, and Metascore approach. Same things we found that the BART model provides good performance, better performance compared to other kind of models. Pegasus models probably provide the poor effectiveness due to the model is trained in the POB medical data set, and in the proposed models in the means used models, some highlights are redundant or inaccurate. We can improve the models by adapting and domain embedding the other care. These are the references.
Any questions from the audience, please? Please give a big hand to the team of everyone. Next presenter is hello. Next presenter is Sharal Coelho. Paper ID is 118.
Yes, ma'am. Can I share my screen now? My screen is visible?
Yes, my screen is
Yes.
visible.
I'll start.
Section so that we can conclude in 5 minutes.
Okay, so I'll start. Hello, everyone. Good afternoon. Myself, Sharal Coelho, and I'm presenting a paper titled Knowledge Extraction, Pegasus-Driven Summarization for Research Dissemination. So the authors of this paper are Asha Hegde and Sharal Coelho and Joyce Mary D'Souza. Okay, so already the organizers has they have given the introduction, so I'll just tell the main focus is on automatically generating the research highlights from scientific paper abstracts. To work on this, we have gone through many related works. So what we found is like BART, T5, Pegasus. So all those models which are used for summaries for general and scientific text, and BART and Pegasus are mainly designed for abstractive task. So based on these ideas, what we have done, we have taken Pegasus as our main approach here, and the objective and core approach here is to develop an efficient abstractive summarization system that condenses scientific article abstract into concise and informative highlights. So our main core approach here is pre-trained Pegasus model, fine-tuned using low rank adaptation, that is nothing but LoRa for parameter efficiency. So LoRa is a parameter efficient fine-tuning method that mainly competitive performance while drastically reducing the memory computing expenses. And as I already told, Pegasus, it is also a pre-trained transformer-based model that is designed for the abstractive text summarization. So to here, we have followed a few steps in this methodology. So I'll be explaining now. This is the block diagram. So the first step we have done is pre-processing. So here the Pegasus tokenizer is applied to both inputs and targets. So like truncating to maximum length of almost 256 for input length and input, and for output it is 64 tokens with the padding to ensure the uniform sequence length. And here we also done the model building with the LoRa. So basically we have taken two methods here, pre-trained models like Pegasus PubMed and Pegasus ArcSci. So it is like Pegasus PubMed pre-trained on biomedical gap sentence generation task. It is actually excels in clinical and scientific precision. And Pegasus Archive, it is trained on broader scientific corpora. Like it is better for interdisciplinary topics like physics, ML, chemistry, all those things. So in the model construction, as I told, we have used two different model variants, like which are trained on like archive data and PubMed data. So both utilizing the Pegasus model with LoRa for efficient abstract summarization. And here, the model is constructed by loading the pre-trained Pegasus base, and LoRa configuration is applied with the R8 alpha 16 and dropout to 0.1. And also we have used a sequence to sequence trainer that is initialized with the adopted model. And here the organizers they have given us mix-sub Sci-Hi data set. It is basically the collection of data from the research articles from Science Directory. And each data instance is structured like as a pair of consisting of abstract and corresponding research highlights. So this is the table for the distribution of a given data set. And here comes our result part. So the performance of the model is evaluating using Rouge metric. So here this is our result table. And for Pegasus PubMed, along with the LoRa, we secured 4th rank with the value 0.2296. And for Pegasus Archive plus with the LoRa, we achieved 0.2040. So this is the comparison of performance across team submissions. So we secured a 4th rank here. And the main conclusion to give, by using transformer-based models, we aims to produce high-quality author-like highlights that achieves a stronger scores. And our work has the potential to reduce the burden of researchers, like enhances the accessibility of scientific contribution to automatic accurate highlight generation. And these are the references which we have used. And with this, I'll conclude my presentation. Thank you.
Okay, thank you for your nice presentation. Our next presenter is Anindita Bhattacharya. Paper ID is 160. Anindita?
Yes, ma'am. Let me share my screen.
Okay.
Ma'am, is my screen visible?
Yes, visible. Only 5 minutes for your presentation, okay?
Okay, sure. Hello and good afternoon, everyone. I am Anindita Bhattacharya from Jadavpur University, and today I'm here to present our research work from abstract to highlight, automatic research highlight generation, carried out by Anindita Bhattacharya, Tohita Rahman. So, as the introductions have already given by some of our researchers, so I'll directly go to our methodology. So, for our research work, we have chosen the T5 base and BART base models, which are two of the most well-established transformer-based models. So, the motive behind choosing these models was the encoder-decoder architecture of these transformer-based models are specially designed for abstractive text generation tasks, and also these models have consistently shown promising results on most of the benchmark datasets. And for the dataset purpose, the SkyHigh track has provided us with the mix-up dataset, which is built by collecting research articles from Science Direct, comprising more than 19,000 articles across multiple domains. And each entry in this dataset contains an abstract along with its corresponding highlight section. And for our evaluation purpose, we have used some standard summarization metrics, which are ROG, Meteor, BART score, and Sky BART score. So just to define a little bit, while ROG mainly measures the similarity by analyzing the word overlaps and the longest common subsequence, whereas Meteor and BART score also focuses on the semantic similarity, synonyms, and paraphrasing to better capture the original meaning of the generated highlights. And Sky BART score, which is nothing but scientific BART score, is an adaptation of the BART score. So here comes our result part. So our fine-tuned T5 based model achieved the best results on mostly all the metrics except for BART score and Sky BART score, where our BART based model performed slightly better. And by achieving a ROGL F1 score of 22.94% for our fine-tuned T5 based model, our team, the NLP Explorers, secured the 5th position in the SkyHigh track at FIRE 2025. And here we also present a qualitative case study that shows an example where it compares the author-written highlights with the highlights generated by the fine-tuned T5-based and BART-based models. And here these colored text boxes indicate the semantic and conceptual correspondence between the phrases of the author-written highlights and the fine-tuned model-generated highlights. So to conclude our research work, so in our work, we explored the task of generating research paper highlights from the abstract using the pre-trained T5-based and BART-based models. So we fine-tuned our models on the SkyHigh track provided mix-up dataset and evaluated using our standard summarization metrics like ROG, Meteor, BART score, and Sky BART score. And both our quantitative and qualitative evaluation shows that these transformer-based models are capable of generating highlights that are stylistically close and also semantically relevant to the author-written highlights. And if we talk about some future research work, so more advanced transformer models like Pegasus or large language models like Llama could be explored also. And also we can incorporate some domain-specific pre-training, especially for scientific articles in fields such as medicine, radiology, etc. And human evaluation could also be included alongside our automatic evaluation metrics to better assess the usefulness of the generated highlights. So these are the references, and this brings to the end of my presentation. Thank you for your time. I'd be happy to answer any questions.
From the audience, please. Okay, thank you, Ananta, for your nice presentation. So, next presenter is Rachana Nagaraju. Paper ID is 77. Rachana, have you joined? Hello? Paper ID 77 of SkyHigh track. Rachana? Okay. So next presenter is Papun Roy. Paper ID is 87. Papun Roy.
Yes, ma'am.
Okay.
Yes, ma'am. Am I audible?
Yes.
Am I audible?
Yes, you are audible.
Okay, ma'am. Thank you. Ma'am, my screen is visible or
No,
not?
not visible yet. Not visible yet. Papun, try to finish within 5 minutes, okay?
Okay, ma'am. Ma'am, my screen is visible?
No, your screen is not visible. Your share screen, but yes, not.
Okay. Thank you, ma'am. Good afternoon, everyone. Today I
Please
will
go for the presentation mode.
okay. Today I will present highlights in generation.
Upon press F5. Go for the presentation mode first. Okay, then start. Start.
Good afternoon, everyone. Today I will present our work on highlights generation from scientific paper using the XGBoost regression model. And this research is conducted at Jadavpur University with Professor Kamal Sarkar, and it is submitted to the FIRE 2025 share. Our goal was to automatically generate highlight from the scientific abstract. We compared two approaches, mainly XGBoost classifier and XGBoost regression model, and the regressor constantly performed better. Highlights are short summaries that help readers quickly grasp the contribution of a paper. Writing them manually is time consuming. That's why we need that kind of thing. There are our mainly four type of contribution there. First, we build a sentence level highlight prediction using XGBoost. Then we overlap. We use string overlap, ROCL similarity for leveling. We compare classification and regression approach, and we provide a complete pipeline with training, validation, and testing. Summarization methods are either extractive or extractive. There are two types of summarization. Extractive selects the sentence directly, and the abstractive method it generates new text. Some deep learning methods like BART, Scibart dominate, but require heavy resources. Those are already our previous researchers said. Heavy resources are there, but our approach it generates some same kind of thing, but our resource will be very low. Our methodology, mainly methodology, if we say, we get the abstract from the FIRE 2025 data set, we tokenize the system, then TF IDF feature extraction, then we assign the label for binary for the classifier and ROGL score for regression. Then we train the XGBoost training those model, and we will get the sentence score and ranking. After that, we get top three sentence selection, and that will be our final highlight. Like that. This is our flow of the work. Now, the XGBoost classifier mainly put the highlight or not. It decision mainly highlight or not using logistic loss and output probability, and regressor mainly fine tuning or produce finer ranking better than and better it generate better highlights. We get the data set from FIRE, SciHi shared task, and derived from the Bootstrap corpus, and we get three different data types: training, validation, and test. Each data set get file name, abstract, and highlight except test data. And our result is this mainly. We show the classifier and regressor, mainly classifier which is outperformed better than regressor. Regressor is better performing approach. This is our chart, and the whole leadership leaderboard will be there, and we place 8th rank in that task. Regression constantly better working approach. Regression constantly better working approach because it is lightweight, resource efficient, and compared to the transformer. Mainly this is the main thing that transformer model use heavy resources, but our approach lightweight and resource efficient. So regressor, XGBoost regressor is effective for highlight generation, but there are some will be some future work, and the future work is includes integrating abstractive reinforcement, redundancy removal, and domain specific adaptation for the purpose future use. We can work on that. Here are the references, and thank you. If there are any questions.
Any questions from the audience, please? Thank you, Pawan, for the nice presentation. Our next presenter is Nishalini K. Srinath K. Paper ID is 84.
Yes, ma'am. I'm here.
Only 5 minutes.
So, good afternoon, everyone. Myself and my fellow presenter, Srinath, are here to present our titled Entity and Keyword Guided Highlight Generation from Scientific Abstracts Using Large Language Models. We were guided by Professor Dr. Amar M. Scientific publications have grown 7% in just 6 years, making it impossible for researchers to really create highlights for every paper. Difficulty is its generation. It's doing it correctly. So directly prompting LLMs often leads to hallucination or loss of domain-specific details. And our key idea is very simple: to guide generation using structured signals extracted from the abstract, such as entities and keywords, and filter entities and keywords, keeping only those appearing in the ground truth highlights. This anchors the model to verifiable scientific content and improves the factual accuracy.
Yeah, this is our architecture. This is our overall pipeline. We first apply basic pre-processing such as the lower casing, stop word removal, and removing unwanted characters to ensure the input is consistent. The first component of our pipeline is named entity recognition. We use a Scibert model fine-tuned on multiple scientific NER datasets to domain-specific entities such as methods, materials, metrics, and biological terms. Because Scibert has a token limit, abstracts are split into overlapping chunks and duplicate entities are removed. We then rank the extracted entities using a domain-specific scheme. Next, we extract semantic keywords using KeyBird. Unlike frequency-based methods, KeyBird uses sentence embeddings to identify contextually meaningful bigram phrases. A key step in our approach is reference-aligned filtering. During training, we retain only those entities and keywords that appear in the author-written highlights. This removes noisy constraint and significantly reduces hallucinations, making it the most impactful factor in our performance improvement. Since LLMs have strict input length constraints, we introduce a sentence ranking and token budgeting strategy. Each sentence is embedded using Spectre and ranked based on its semantic importance, with additional boosting for sentence containing entities and keywords. Only with the most informative sentences are selected to fit within the token budget. Finally, we fine-tune Llama 2 with 7 billion parameters using QLoRa, which enables memory-efficient training on limited GPU resources. The model is trained using instruction-style prompts that include the trimmed abstract along with the filtered entities and keywords, helping the model to generate concise and factual research highlights.
This is our results table. We evaluate 6 configurations. Our best model V6 combines trimmed abstracts, entity and keyword guidance with reference aligned filtering. It achieves the highest Rogue and Meteor scores across all settings, and this confirms that carefully curated guidance is more effective than simply adding more information. One limitation of our current setup is the 512 token limit, which restricts how much context and guidance can be provided to our model. With access to higher end GPUs, future work can extend the input length to 1024 tokens or more, enabling richer context and more coherent highlights. Additionally, expanding cyber training to include more scientific NER datasets can further improve entity quality and coverage, strengthening guidance during generation. Thank you.
Any question from the audience, please? Okay, please give a big hand for the team. Thank you, Michalini. Okay, our next presenter is Vainika Shamanto. Paper ID is 82. So good afternoon, everyone. Respected session chair and distinguished panel members and fellow researchers. It is a great pleasure to be here today. And I am Vainika Shamanto. I will be presenting our work titled Automatic Semantic Summary, Scientific Summarization and Neural Approach to Research Highlight Generation, which was carried out jointly with Dr. Faridha Ranjan. So, in introduction, I will keep it short. The rapid growth of scientific publications has made it increasingly difficult for the researchers to stay updated. Although abstract summarizes the paper, but they are often lengthy and not structured for quick understanding. So my main motivation for this project is to highlight the research work, research highlights which present the paper's key contributions as a short bulleted points. This which addresses the issue of lengthy and not structured. However, generating them manually is very time consuming, and our work focuses on automatically generating research highlights from the scientific abstract using neural networks.
So we have used the dataset mix up SciHive, which includes 20,000 scientific abstracts paired with the author written highlight. For the FIRE to 2025 SciHive shared class, the dataset was divided into training, validation, and test sets. So these are the related work I have gone through. Now moving on to the methodology section. In our work, we have employed the T5 text-to-text transformer architecture. T5 treats every task as a text generation problem, allowing both inputs and outputs to be represented as text. The abstract is provided as an input to the encoder, and the decoder generates concise research highlights in a bullet style format. We selected T5 small due to its efficiency and suitability as a strong baseline for this task. Now moving on to the experimental setup. Before training, we have applied standard pre-processing steps, including the text cleaning, normalization, and tokenization. The model was trained for 3 epochs with a maximum input length of 256 tokens and the output length limited to 30 tokens. Now, the evaluation matrices, we have used Rogue Score and Meteor. So, our fine-tuned T5 small model achieved a Rogue F1 score of 17.91%, along with a Rogue 1 score of 26.23% and a Meteor score of 18.71%. Based on the official leaderboard of the FIRE 2025 SciHive shared class, our system ranked 10 among all the participating teams. This result indicates that even a lightweight transformer model can efficiently generate a meaningful research highlights. So there are a few limitations in our model, that the models due to the small model size, it restricts the deep semantic understanding, and the data set is also limited to research from 2020 domain dates. So in conclusion, I would like to conclude by saying that our work demonstrates that fine-tuned transformer model, particularly T5, provides a strong baseline for automatic research highlight generation. And while the approach is effective, there is also always a room for improvement. Future work will explore larger models, richer semantic evaluation metrics and methods to enhance factual consistency and abstraction. Thank you for your time and attention. Any questions from the audience?
How are you trying to incorporate RL?
Yes.
Incorporate learning.
Sir, actually that we have not planned yet, but we would like to do more domain. Yes.
Like how are you going to incorporate RL? What way?
That we have not decided yet actually. We are planning on doing the research.
So after that, we have a very important session, that is lunch break. So before that, I would like to request my co-supervisor as well as the coordinators of SciHive track to say something as a conclusion message. Please, sir.
Well, I have a request. This is quite an interesting problem because me myself, I have been working since my PhD in this particular domain. We are the first to actually develop a meta-review generation system by taking into account the expert review and all. So my request to the organizer will be, it will not be fair to judge the team just with the help of Meteor and Rogue
Okay, it would be interesting to at least think of it because there is a specific order in the highlight you can see. Right now it is just a order, right? So there is a particular order. Generally, researchers do not highlight their result as a first. It is something like a background or something, then methodology, and at the last part of the result section will come. But right now, not even Meteor or Rohan or to Google are able to capture that particular thing. So my suggestion would be, if you are planning to have this try again in future, try to incorporate completeness or coverage will be one important metric for this particular coverage or completeness, followed by factual consistency. Yes, I think some of the team has already highlighted factual consistency will play a major role here. And now nobody has used LLM-based model. So we are still using the traditional model, Roman, Roku, and Google, although these are the state of the art. But when you are using LLM-based model, why do you use traditional-based evaluation method? So there is a standard one C-score. I think most of you have heard about that. C-score, similarity, entanglement, and acceptability. So I think C-score, relevance, coherence will also play a major role, and factual consistency and reliability. I think these are some of the important metrics will be useful to incorporate in. So this is a really yes, yes. Okay.
Thank you. That's a great suggestion for us. And very frankly, we thought of using 50 score of score that where we didn't use it as a chart because there are a lot of these documents, but they that would require access to the this models, large language models, which is not free. Okay, so it would be better if we can train a metric which can be for this purpose and which is free because so many because the more the number of teams, the more the cost comes. That is a two consideration, one consideration. And regarding all those metrics that we told, it's very important, really very important that we taste these things. Right now, our, as I highlighted, our evaluation scheme is very limited, very primitive. So yeah, that is one way to go ahead. And another good suggestion was to extend it to multilingual setups. That I still do not know whether it is possible because we really don't have very good scientific journals to the best of my knowledge in many Indian languages. Okay. So maybe one way is to convert, but then the quality of translation is also suspect sometimes. So yes, it's a very difficult problem. Yes.
My suggestion will be, I mean, don't go for translation because that defeats the purpose. Okay. So why somebody will look into Bhardander journal? Okay. One reason, maybe one possible reason that they are not that much comfortable in English. So if you do the that translation, then even though it can be an experimental work, but taking the big picture in mind, that is not going to serve the purpose. Original journal made for.
So maybe after the highlights are generated, we can translate the highlights in the local languages and go to the users and ask them whether they are satisfied with it or not. Because really for the last 1 year, we have been trying to formulate this problem of multilingual presentation of scientific abstracts, but we couldn't find the proper use case or the real benefits of that. Okay, because large scale translations are very difficult. The words, the meaning schemes, considerations doesn't happen properly. There are lots of issues. So that's a part of the bigger picture. And I think once implemented, we translate the highlights to local languages and ask the experts to give their comments whether they are readable, whether they are satisfied with it or not. That's one thing. So I hope next year we'll be able to organize a track again and there will be more participations. Thank you very, very much. And I thank the organizers, Professor Kumar Pal, Professor Putinda, Satibashish Kambuli, and all the keynote speakers who have been giving wonderful talk and inspiring us to go ahead. Thank you very, very much.
Thank you. Lunch.
We have a lunch break first. We have a lunch break, but before that, one announcement for track organizer, speakers, and all the organizing committee. Like we have a steering committee meeting today at 5 p.m., 5 to 6. And after that, we will go to the banquet. So I think banquet venue. Yeah, backward is for everyone. So when is
Okay, so for banquet, maybe after once we come back from lunch, and when we're about to leave for the banquet, I'll make the announcement of how we would be reaching there and what is the time. I think that should work. Yes. So it's lunchtime. Let's meet at probably 1:30.
viewing
there is a challenge in the question side while talking about Indian language. So nowadays large language model is in large. Most of the tasks are being performed by using large language models. So if LLMs probably say very high zero shot transfer learning, but in zero shot performance is in most of the cases it is uneven across Indian languages. So in some languages like Hindi it performs well, but by talking about other low resource languages of India it performs quite bad. So is it better to rely on powerful zero shot multilingual model, or we can invest in some kind of fine tuning so we can improve the result of these already pre-trained models. So the main motivation behind this task is, as we all know, full fine tuning can be quite expensive. So we'll go for a few shot learning. So we'll try few examples of question answering, and we will see how it really works. How it really works when we go for a zero shot in most of the already pre-trained models. So our key challenge is to build strong QA systems under realistic constraints. So talking about realistic constraints, so what I mean is where we do not have much compute resources. So the two research questions which I have answered in this research work is how effective is zero shot cross-lingual transformer in the QA, and can minimal fine tuning yield meaningful gains in the evaluation matrices. So for this task, what we have done is we have taken a Hindi question answering data set which was provided by AFR Bharat. So it contains around 10 Hindi languages, and these are the statistics of the data set. So each row contains a question, an answer, and a context. So based on the context, the question is being asked, and the answer is being extracted from the context. And as we can see, there are some unanswerable questions also. So the answer of those questions are not present in the context. So this is the full statistics of the data set which I have taken for this action. And these are the 4 models which I have worked on for zero shot and also for fine tuning. So most of our pre-trained in all Indic languages except the part phase. So it is pre-trained only in English. These are pre-trained in Indic languages but are not fine tuning question answering for any Indic languages. And for zero shot experiment setup, we don't so that these models do not have any. These models are not trained in any Indic question answering data set. They are only fine tuned in the English quad data set, and we did a direct evaluation of the Indic QA test. And these are the results of the zero shot learning what we have achieved from those models. And after this zero shot, we saw that XLM Roberta Large was the best performing model in all the languages. So what we did was we picked that model and then fine tuned that model on 50% of the data set, and we fine tuned it for 1 epoch, and these are the results which we obtained after fine tuning. And as you can see, we have attained we have improved the result of F1 and exact maths by about 10%. So what you can see is that using the large model for large pre-trained model in zero shot, it gave us a better result as compared to the other models. And while we did minimal fine tuning, that is only 50% of the data, we also achieved a better F1 score and also exact math score. So the best strategy as a resource constraint is that we can begin with the strongest multilingual pre-trained model to maximize transfer, and then we can apply fine tuning on a small amount of data to enhance the result or to increase the result of the evaluation metric. So the main limitation of this work is that we only give for extractive question answering, and we only give in a very small data set. So we can increase the size of the data and also go for extractive question answering. And we can also fine tune on all parameters. We did fine tune on only the upper layer of the pre-trained. Added a layer about a pre-trained model, and we fine tune on in that layer. We can add more layers, and we can also increase the model complexity. And the conclusion is that zero shot therefore provides a strong baseline. Performance is uneven across Indian languages, and minimal and unique is highly effective in in resource constraint scenario. Thank you. Are there any questions from the audience?
So you said that the performance is not consistent across all Indian languages?
Yes.
So did you try to find out why is that the case? Like some insights?
I have not explored it now, but as I can see that in some scenario, while talking about the data set, in languages like Hindi, Bengali, the amount of data are quite large. And I believe that that might be the primary cause for having a better performance in those languages. There are some Indian language related, right? Not in words, but in the upcoming word, right? Any other questions from the audience? No, then this thank the speaker. So now I request Dr. Devanshi Sharma to go over and introduce our new speaker, who is being even invited to talk.
And so the audience listen to me. Hi, Dor, are you online?
Yes, I am online. Can you hear me?
Yes, I can hear you. Yeah, so we'll proceed with the talk, but let me introduce you and the purpose of this talk. So this is going to be a talk about the journal IRRJ, which is kind of successor for the previous journal IRJ, which we had to close because of open access issues. So Dor has got nice solution for open access issues, and this journal is completely diamond open access, so it's going to be quite a good thing for our community. And he's going to describe a lot more about the journal. And then he's going to discuss ways of collaborating, fire conference track papers, and ways of extending that into this journal. So, word if you can.
All right. So thank you, Debasis, and it's an honor that you invited me to present a new journal. So can people see me on the screen?
Yes. Yeah.
All right. So yeah, so my name is Jude Hiemstra. I'm the editor-in-chief of the Information Retrieval Research Journal, and let me see. You can. This is it. It's. I didn't prepare slides, but I do have some information about the journal. So IRJ is the only peer-reviewed diamond open access journal that focuses exclusively on IR. And when I say diamond open access, I mean that it's free and unrestricted online access to all the papers, and that the reader does not pay, so there's no subscription fees. And the authors do not pay. There's no article processing charges. So that means we run fully on volunteer work by editors and reviewers. And if we're honest, that's also what the big publishers and the predatory publishers do, right? I hear some sounds, but I'm still there, right? Okay. Okay. So additionally, we have some volunteers. There's a production editor that sort of nags about tiny details in PDFs, and there's a webmaster. And of course, there's some costs involved in running the journal, but definitely not like 100,000 rupees per paper, which is, I think, ridiculous, and I'll get back to this. But we do need some funding, and we try to be completely self-funded. We run on micro donations. We might open sponsorship later next year. And we run on resources and infrastructure provided by friend organizations and universities. So at this point, my university, Radboud University, together with the Dutch Royal Academy, provides resources, basically a web server that runs the software. But it's good to know that Radboud University does not own the journal. Sort of we as the community own the journal, and at some point when I retire, as editor-in-chief, I don't plan to do that in the recent future, but some other university can take over. And we run open source software that's developed by PKP, that's the Public Knowledge Project, and basically anyone can run this journal. So why are we doing this? So currently IR papers are published at journals such as, in conferences, right? You go to SIG-IR, or you publish at ACM Transactional Information Systems. The conferences ECAR and CLAY publish their work at Springer. And there is, for instance, also the Information Processing and Management Journal at Elsevier. And these papers are either behind paywalls at Springer and Elsevier, or they require authors to pay for open access, or both. So currently, and I looked it up, you pay about 90,000 rupees for a SIG-IR paper, 160,000 rupees for an ACM Transactional Information Systems paper, 260,000 rupees for an ECIR or CLAY paper for it to be open access, and no less than 330,000 rupees for an IPNM paper. While some researchers, including me, we work at universities that have agreement with some or all of these publishers, and in that case, I'm not really seeing these costs, right? I'm not directly paying this, but my university does. And I believe many of the Indian universities are part of ACM Open. But how many take part, for instance, in Springer and Elsevier? And if you're not part of something like ACM Open, and let's be honest, almost all of the IR papers are at ACM, then you can probably also not afford to pay this 90,000 or 160,000 rupees for a single paper. So some of our researchers cannot afford to publish in IR, and they are basically not part of our community, right? And some of them are in India, but there's also colleagues of me in Europe, in countries like Romania and Bulgaria, that tell me, hey, I'm publishing in NLP because that's all open access. I cannot afford to publish in IR. And there's countries in Africa, in South America, Southeast Asia, the Middle East, and all of these researchers cannot truly be part of our community. So they cannot read the papers, or they cannot publish the papers, or both, right? So that's the reason why we started IRRJ. We believe that we need open access without fees, build a diverse and inclusive community, and we want to build this community with researchers from all over the world. So many people have asked me, like, hey, but how can you compete? How can IRRJ compete with the big publishers? And yes, we can do everything that they're doing, and we can do more, I think. So we have an ISSN number, we have digital object identifiers, we have a dedicated and diverse editorial board. And if you ask me, our editorial board is much better than some of the other boards. We have clearly stated peer review policies. If you publish with us, we have a clear, established, common Creative Commons license. Basically, authors retain all rights, and if you publish with us, you don't have to sign anything. You just publish with us, you agree to the rights, and yeah, in theory, you could maybe even retract the paper later. But I don't know why you should do that. But so it's your paper. We have an established rolling publishing schedule, so that means that as soon as the paper is accepted and we get the final version, it will be put immediately online. And we also have at least 2 paper issues each year. So at least we have paper issues this year. I still don't have funding for paper issues. And to be honest, most people don't really need paper issues, but we just wanted to show, hey, we are doing everything that others are doing as well. Many don't have paper issues anymore, actually. So one thing is that we're working very hard to be indexed by all the academic search engines. So we're indexed by DVLP, by Crossref, by Google Scholar, and we will be indexed by Scopus and Web of Science, but that will take a bit of time because they only take on journals that exist for about 3 years. And it also means that we plan to have a journal impact factor, but that will also take about 3 years. So we plan to have one in 2028. All right, I hope I don't take too much time. So there's one more reason that we did this, and Debasis already mentioned this. There used to be an IR journal published by Springer. It existed for about 25 years. It was founded by Cantor and Stephen Robertson. Springer discontinued the journal early 2024. And Paul Cantor and Stephen Robertson, the original founders of the old journal, they form now the advisory board of IRJ. And so we are kind of the unofficial successor of the IR journal. Actually, I contacted Springer to take over the journal, but they refused. I'm not very surprised, but it was worth a try. Paul Cantor wrote the editorial of issue 2 it's already online, and we're now finalized the second issue of this year. I already read it. It's a nice paper discussing how IR and the current AI hype are related, and how we should be critical of AI, at least generative AI. So yeah, so please publish in IRJ, and then it's an honor I can make a couple of official announcements. So the first is there will be an IRJ special issue of FIRE 2025, with extended papers of this week's conference. And the guest editors of the issue will be 2 of the FIRE conference track coordinators. So Debarshi is from the Indian Association of Cultivation of Science, also one of IRJ's associate editors. And Debasis Gamuli from the University of Glasgow, who I know from his time at Dublin City University quite a while ago. And the guest editors will invite participants of FIRE to submit extended versions of their FIRE paper, which should contain about 50% new material. For instance, an enhancement that improves the technique that you described in your FIRE paper, or maybe a test on an additional data set, or some additional analysis of your algorithms, stuff like that. So the submissions will open in January. So as soon as possible, and the deadline for submission will be in about 5 to 6 months, probably end of April. And the special issue will be published later this year in 2026, later next year. So yeah, so I'm very excited. This will be the first IRJ special issue, and it's very nice cooperation of IRJ and FIRE. I also hope that some of the IRJ authors will present at next year's FIRE, and actually I'm pretty sure they will, because of some of this year's keynotes by Bhaskar Mitra and Jaap Kamps, also published in volume 1. Yeah, I'm very excited that this will happen. So thank you, people from FIRE. Thank you, Debarshi and Debasis. And then I think I have another announcement, right?
Yes, before we start on that, George, I just want to ask you a question about the average time that it takes to review papers. Once you submit that to the journal, what's the average lifetime of a paper before it gets?
So our reviewers get quite limited time, but it sometimes takes a bit time to find the right reviewer. But we definitely aim at very similar reviewing time as, for instance, SIG-IR. So when your paper comes in, you should have a yes/no decision in about 3 months, sometimes sooner. And then that decision might also involve, which is not possible at SIG-IR, but it might involve some revisions of the paper, right? And if you look at our papers at the top, you can see when they were submitted and when the final version was accepted. So you can have a very, but we're quite transparent about this. So you can, per paper, you can see how many times it took. I don't know the average from the top of my head, to be honest. Yeah.
Yeah, I think it's a very good opportunity, and thanks to you that you're providing this opportunity to the FIRE participants and the FIRE conference track participants, authors, who are getting a chance to expand their papers and send this to the journal, which I think really is a very good opportunity to move forward. And we also have an announcement for the Best Paper Award and the Best Honorable Mention for this year's conference track, which I'll be very grateful if you can announce that on our webinar.
Yes. Okay. Oh, this is exciting. So should I start with the honorable mention?
Yes, I think you should start. Yes, and then we can move on to the rest.
Okay. So for the best paper of FIRE 2025, an honorable mention goes to the paper Towards Ayurveda Information Retrieval, Challenges and Opportunities by Pranav Shukla, Vandana Dhingra, and Girish Tilu. So congratulations.
Here, so maybe we can come. We don't have the certificates, we'll get the certificates. The shake has to do for the time take or the identity have. But very, very well done. Do you want to get a picture? Maybe with Jordan as well. I think that's Jordan, we're taking a picture with you. Thanks a lot. Well done. And we can now move on to the best paper award, which we're going to disclose now.
All right. So hold on to your seats. The best paper is a paper titled Dynamics of Character Embeddings in Indian Mythology, a physics-informed neural network approach by Apu Badapol, Anish Goswami, Sanik Mahata, and Dipankar Das. So congratulations.
Please come over. Yeah, I don't have certificates, but really, really well done. That paper was great. You want to get a picture with Jordan as well? Yeah. Again, we're taking pictures with you, Jordan.
Okay. I will smile.
Yes. Come see us with country.
Okay, congratulations. And I hope the authors of those papers will send in an extended paper of their paper to the IR.
So thanks a lot, George, for joining us again and disclosing the best paper awardees and also talking about the journal. It's a really good opportunity. I'll be looking forward to guest edit the special show.
You're welcome, and I wish you all the best with FIRE. So thanks for having me.
George, so there's a question for you from the audience.
Yes. I mean, certainly it's a good idea to have an open access journal which can be published freely, no purchasing fee. My question is, I mean, certainly, in recent times there have been, huge increase in the number of journals, because a lot of interdisciplinary areas are being explored and journals are coming up in those areas. But I don't see matching increase in the number of reviewers and editors, right? So therefore, there is a delay in the publication across the journals. I mean, a lot of papers come to us which we are not able to complete in time, and it gets delayed. Okay. And another important point is in the business model of the journals. I mean, these journals are basically business houses. I mean, who do the business based on our volunteering work. I mean, in the process, neither the authors or the reviewers or the editors are getting paid. From the authors or editors, reviewers, it's a voluntary service, but they make a business out of our voluntary service. So, so what is the business model? You have, so how the publication will be, cost of publication will be managed, okay, for your journal. If you can.
Okay, thank you. So I think you had two questions. One is about how to get enough reviewers and review things in time, and the other one is what's the business model of the journal. And so about the reviewers, actually, lots of people were very enthusiastic and about the journals starting, and I think we have a very big list of people in the editorial board now, and most of the reviewers now only review a single paper per year or something. But of course, we also hope to grow. So that's definitely a concern. What we try to do is invite reviewers for a year, pretty much like for a conference. But then there's not a fixed deadline for your review because it depends on when the paper is submitted. And about the business model and who's getting paid. So I said we're all volunteers, but if I'm really honest, the university pays me, and the university pays me quite well. And as part of my job, I'm reviewing papers, I'm organizing conferences, and I used to do a lot of volunteer work for SIG-IR, for ECIR, and a couple of other journals and conferences. And now I stopped doing this, and in this basically the same time, I set up this journal, and I'm doing all my volunteer work for which my university pays me for the journal. So and in a sense, they're now paying me for something that's is not going into the pockets of Elsevier or Springer, or I don't want to be very critical about ACM. I was an ACM member for a long time, but they're also this ACM Open. I'm not sure if you've seen there's a premium version, but yeah. So I am getting paid, obviously, but it's so there's not another business model than we want to publish nice papers, high quality papers, provide good reviews, and help the community further. That's the business model.
Okay, I think in the interest of time, we should get the presentation for this. And thanks a lot, George. Have a Merry Christmas and Happy New Year. We'll see you.
Yes, thank you. Happy New Year, and thanks for having me. Okay.
Bye-bye.
Bye-bye.
Accept the invitation for the wonderful talk, and I hope that we'll have some extended papers submitted from across the branch of fire. We'll have the special issue by the next year, I think. So thank you very much for your time. Bye.
Yeah, you're welcome. Thank you. Bye-bye.
So we already had a presentation from Mohammed Ashkar, and the next talk is analyzing abuse content in Indian international language. It's also present here. So before you start, there was a talk that was do online, which is novel zero talk framework for English cross-lingual. Is the author online? Is the author for the first paper schedule?
Yes,
online?
yes, we are online.
Okay, so we'll have your talk as the last talk of the session.
Yeah, sure.
And we'll continue with the normal schedule and have it.
Hello. So good afternoon, everyone. My name is Harshvardhan Nepalwar, and I'm a final year student at 50th Central College of Engineering, Pune. Yeah, so I'm a final year engineering student. So I'll be talking about on our work analyzing abusive content in Indian vernacular languages, a case study of Marathi and Bangla. So we'll be focusing on two or rather three languages: Marathi, Bangla, and somewhat of. So keep in mind that this study is focuses on systematic experimentation. It focuses on systematic experimentation and analysis rather than just building classifiers for the sake of it, and studying how cross-lingual analysis and analysis of cross-lingual language. So these are the topics which I'll be going through today. So we yesterday, like Mr. Mukherjee sir gave the introduction about fire and fear of it. Similar was our motivation, like low resource languages like remain underexplored. Addressing abusive content in low resource languages is essential for inclusivity and equitable energy system. So when dealing with low resource languages, these are the common challenges which one faces, like resource scarcity, high quality, large annotated data sets, limited pre-processing tools, robust tools, and the task complexity increases with the code mixing, like yesterday it was talked about irregular spelling and dialect as well as the regional variations, which the one has to face. So our objectives are threefold. We start with systematic multilingual experimentation starting with Marathi, going towards Bangla, and then finishing off with Hindi. Then we move towards cross-lingual transfer analysis and comparative analysis. So we aim to provide a unified pipeline, a unified experimental framework for analyzing abusive content. So let's start with the datasets for Marathi. We have used the Mode 2.0 dataset. It's a publicly available dataset. It consists of around 3,600 data points, and it is based on the OLID based schema, like the offensive language identification schema, and there are three subtasks in this. So so for subtask A is binary, subtask B is also a binary. And subtask C is multi-class classification. For Bangla, I've used the bad data set. It is also publicly available data set, which consists of about 14,000 data points and consists of four major categories. The religious aggression, political aggression, verbal aggression, and gendered aggression. So, like I said, similar task. First is binary classification. Subtask B is also is multi-class classification, and subtask C we use the same class set as that of subtask B, but we included it for a deeper semantic understanding and fine tune. For Hindi, we use the HASSOC 2020 data set. We know that it is a 2020 data set, but it was the only feasible one which we were able to find for now. Consists of almost 3,000 data points and consists of two tasks, binary classification and 5 range. So this is the general pipeline. We start off with the data set input, selecting the language, providing the data set. Then we move towards the pre-processing. Mind you that in this all these three for Marathi Bangla we have used the same pre-processing, same meaning like the architecture of the models remains the same for controlled experimentation. That is what we were aiming for. So there are like transformer language specific word models and PFIDF, the traditional feature extraction method as well. Then we move towards the feature fusion and depending upon the model which is used, we move towards training, optimization, and then evaluation. So for we have used and we have worked on another model. So we select the best performing models for Marathi. There are 5 models. For Bangla, there are 5 models. And in Hindi, we use direct transfer learning of the best performing models of Marathi and Bangla. And the model categories are the traditional ML classifiers and those, the ensembles, as well as the transformer based approaches. We have not gone with the LLM large language model approaches, but that is included in our like future works, and we are definitely working on it. So these are the models which are used, and I go towards the results. So so there are like I said for mode 2.0 there were 3 subtasks, and we see that there is a general concept misconception that binary classification is easy, but we see that this is not the case for this data set because subtask C it's the multi-class problem. The accuracy for it there is low. So this arises because the annotation or the binary classification data set has more of what you can say noise. So that's why we observe such kind of performance, and we see that random forest plus Mahavik bird, which is a transformer developed by NCQ, gives the best results, and ensemble models perform better. For Bangla, these were the following models which we used. I will directly go towards the results. So yeah, like I said, the same architecture, the best of the first I started working on, we started working on Marathi. The same architecture was used as it is, and then we applied it for Bangla. So, but here we see that binary classification task is better as compared to the multi-class classification. So from retraining in language specific retraining, it enhances the results. We'll be moving towards the cross-lingual transfer analysis. So we see that we start with Marathi to Marathi obviously trained in Marathi region, so the performance is at its best. But when we directly apply language-based models from Marathi to Bangla, we see a significant drop. Then again, we move towards Bangla to Bangla, same case, trained in the local fine tune as well, so Bangla as well. Bangla to Marathi, significant drop. Marathi to Hindi also drop, and then Bangla to Hindi again and again. So one general point would be that Marathi and Hindi are use the same script. So why weren't like the result should be better for Marathi to Hindi rather than Bangla to Hindi. So this is addressed by the case of annotation and a deeper semantic meaning. So that is what plays a major role in this, and that's why we observe this kind of result. So these were the transfer learning work done on Hindi. So the best performing model, the L3 cube highest word which was used, and the best Bangla model was used. So although the result is not great, but it is not random. Yes. So like I said, the current models are effective, but exhibit limited conceptual understanding. So our results show that current models focus on surface level cues and struggle with deeper semantic distinction, especially under low class like the datasets here are very small. So this study highlights both progress and basic conclusion contents. As I said in few words, we're working with Linux and yes, you can hybrid architecture. The other explanation. Thank you.
For the wonderful job, do you have any questions in the room?
You'll be using Hindi, Marathi, and Bangla, right? Yes. So I was curious if you can cluster the languages based on their, cultural similarity. For example, Bangla and Assamese is an example, right? And maybe do these transfer across these two, then this makes more sense because Marathi, Hindi, I do not think they are, results do not really unearth what is going on inside, right? But at least you can motivate experiment a bit, more meaningfully. It can be the dialects of the same language. Maybe the same language is not spoken or written the same way across India. There can be dialects of Hindi also. So the overall idea, I'm just curious, what was the thought process behind choosing Hindi, Marathi, and Bangla? They don't look all the same.
Yeah.
Yeah. So, yes, sir, they do seem a bit or like randomly chosen. But let me start off by saying this was done as a part of my summer internship with so I started off with Marathi. I started off with Marathi as it's my mother tongue, and then I moved towards Bangla. That is because my mentor, Dr. Sanga Chaki from Triple IT Pune, he is Bengali, so he helped me choose the language, and then Hindi was taken as a base. So I'll definitely work, like you said, the clusters do make more sense, and I'll definitely add it in my future thing.
Yeah, just one thing to add. Lata Mangeshkar, when she sang because when she sang Bengali song, she had to learn Bengali from scratch. The language, the idea of Marathi did not help. That is why I'm thinking maybe, or maybe when Bhupen Hazarika sang Bengali song, it was more useful. That's when I sang it. That is what I. Yeah, thank you.
Thank you.
I see the interest of time, we have to move forward. So thanks a lot to the speaker again. So I think we're running a bit late in the schedule. So before going on, it's already time for the invited talk. But before going on to that, I think we can have the online session first, which is should be like 10 minutes. So the first speaker of the session who is supposed to be online, can you please identify yourself?
This is Raja. We, me, Lata ma'am, and Adarsh are the authors of this paper.
Yes. Can you please start sharing your screen, and whenever you're ready, try to finish your talk within 10 minutes.
Actually, I have shared a video with the team.
Okay. No, but if you're online, then why don't you just give a presentation now? Okay.
Actually, one of the authors are not with me, so that's why.
Okay, that's fine. So let's play the video and speakers are online for answering any question.
Evening, ma'am. Are going to talk about our new book. Good afternoon, everyone. Myself, Adarsh, with my teammate Kulichetti Rajamukesh and Dr. Lata are going to talk about our new work. That is Global Zero Shot Framework for cross-lingual ancient Sanskrit text accessible to the modern researchers and practitioners worldwide. Let me set the stage that I am going to tackle. Sanskrit with over 3,000 plus years of evolution of philosophical and spiritual wisdom. Raises significant barriers to accessible. First of all, we have extremely scarce parallel data, less than 5,000 Sanskrit English pairs, because of which, as compared to millions of modern languages. Second, Sanskrit linguistic complexity is immense. It has 8 grammatical phases, extensive compound formations, and morphological richness that makes direct translation challenging. Most critically, Sanskrit contains cultural concepts like dharma, direct English language. So this creates a fundamental.
I think your video is not playing properly. So can you give the presentation online right now? There's some issue playing the video.
Yeah.
Yeah, you can just options where probably you are not very comfortable or confident. So you can just gloss through those parts and get overall idea of the paper.
Yeah, I'll just give a brief about the paper. Should I give a presentation?
Yes, please share your screen and start
Yeah,
the presentation.
I'll just start with the presentation in just a second. Is it visible now?
Yes.
Good afternoon, everyone. We have written this paper on novel zero shot framework for Sanskrit English cross-lingual information retrieval.
Can you just skip the intro and then go to the main part of the paper because we don't have much time left?
Yeah. So basically, what we are trying to face the problem is we are having scarcity of data, and we are trying to integrate Devanagari languages and try to find semantic inference with all the languages. So basically, we have applied 3 methods. That is cross-script transfer learning, few-shot LLM prompting, and parameter efficient fine-tuning. Hello.
Yeah, no. Yes, you are audible. Please continue.
Yeah, sure.
So yeah, myself Adarsh, I'm also a Ramesh. So what's as I said, we did the three component integrated framework. First we use cross-code transfer because Sanskrit, Indian, Marathi, Nepali all share the same Devanagari script. So we thought that we might use that and increase the parallel data. So we did that. And then Hindi alone shares like 85% of the phenome overlap with Sanskrit and 60% of vocabulary, Hindi's vocabulary is from Sanskrit. So we did that. And we employed few-shot LLM prompting with 5 carefully curated Sanskrit English examples. So these examples provide like contextual understanding for concepts like consciousness, ethics, and liberation. We will see what are the 5 examples later. And third, we used a parameter efficient fine tuning using LoRa. So which we use like 80% of it, like we only tune like 0.8% of the model's parameters. So what we did was like we optimized their weighted combination through gradient descent to create a synergistic effect out of it. Next.
So this is the architecture we have at our hand. So we have 3 parallel pathways that feed into a final score integration. This cross-script transfer component processes Sanskrit queries alongside Hindi, Marathi, and Nepali parallel corpora, totaling around 18,000 equality pairs. And we are also using few-shot prompting pathway uses, which uses 5 curated examples to provide contextual understanding through LLM models. This LoRa fine-tuning pathway adapts our base XLM Roberta model with minimal parameter updates. All 3 components produce similarity scores that we combine using learned weights like alpha, beta, and gamma.
Next slide.
Yeah.
So as I said earlier, so the cross-script transfer is the most novel contribution that we have done. So say in this example, Jana means Hindi for Nyan and in Hindi and Nyan both like same meaning, which refers knowledge. But Dharma remains Dharma for righteousness. So these aren't just like surface similarities, and these are like the thematic spaces that we can exploit. That's what we thought, and we worked on it. So what we did was we actually used like 10,000 Hindi pairs, 5,000 Marathi pairs, and 3,000 Nepali pairs. Like we expanded the parallel data, and then we worked on it, and then we used a Cohen's kappa value of 0.82 to the thing to do which good normalization, alignment learning, and cross-lingual embedding to the knowledge transfer to a shared semantic space. This is what we did.
So coming to the implementation, so our few-shot approach uses carefully structured prompts and with 5 examples covering core Sanskrit concepts. So for example, each example shows an English query, relevant Sanskrit tense, and relevance judgment. Now we found 5 examples to be optimal and to provide enough context for understanding, but not so much that we exceed prompt length limits. These examples span consciousness, ethics, yoga, liberation, and action, the core themes in our Sanskrit corpus.
So speaking about the data set that we used Anveshana data set. So this was available in Hugging Face, which has like 3,400 pairs of Sanskrit English query document pairs. So what we did was 2:1 negative sampling. So all the query and the document were previously properly maintained, but we don't want that properly aligned documents to be fed in the model. So we made a 2:1 negative sampling. So increase the corpus size, and then we split the data into like 732 of training, then validation and the testing, and then we proceeded with our thing. So we did our base model is XLM Roberta with 287 million parameters with the rank of 16 we used. So we didn't use like all the parameters. We only used like 2.2 million parameters, and 0.8% as I previously told. So all these, with doing all these, next will be the results part. this is the results that we have achieved.
So the results we have achieved is our combined framework is achieving an NDCG of 0.5847, which is representing an 80.2% improvement over the baseline XLM raw beta score of 0.3245. So cross-script transfer alone gives us an improvement of 47.9%. And when we combine all the components, we get 80.2%, demonstrating clear synergistic effects.
With all this in consideration, we also took like p-value of 0.001. That's where we did the significance test. And yeah, next slide. So our ablation study reveals that the script normalization gave us like 12.3%. The alignment learning, as I said earlier, gives like another 13.5% increase, which leads to 25.8%. Few shots leads to like 3.5% something, then 2.7%. So it gives you like 28.5. So looking at cross-script transfer by language, NDCG at 10 of 0.2456, Hindi gets the most highest. But combining all, we got like the highest, like 0.4977. Yeah.
So this confirms our hypothesis that multiple related languages provide complementary information that no single language can capture alone.
Yeah.
Okay. So our current model is domain specific to Srimad Bhagavatam. But these represent opportunities for future enhancement rather than fundamental balance.
Yeah.
Could you just wrap up in 1 minute in the interest of time, please?
So to conclude, we have presented a novel framework that combines cross-script transfer learning, few-shot prompting, and parameter-efficient fine-tuning to achieve an 80.2% improvement in Sanskrit-English IR without requiring Sanskrit-English parallel training data. Our cross-script methodology exploiting Devanagari similarities is generalizable to all script families, and a parameter-efficient approach makes the solution computationally practicable. So looking ahead, we are excited about expanding this framework to other ancient languages like Latin, Greek, and Arabic, since they don't have that much parallel data. And we are also exploring multimodal integration with manuscript images and developing question answer system for philosophical queries. Yeah, that's it.
Are you done with the presentation?
Yes,
Yeah,
yes, we are done with the presentation.
Okay, thanks a lot. Okay, so let's thank the speaker. We're already running behind the schedule, but one quick question maybe from the audience.
Yeah, can I ask a question? I'm online.
Online, yes, go ahead, please.
Yeah. So, yeah, Dr. Raja, why do you call it cross script? Because the script remains Devanagari, right? For Marathi, Nepali, or so why do you call it cross script?
So cross script, I'm calling it as in sense that I'm trying to find semantic similarities between English and Hindi, to be exact.
No, but so that refers to language, right? Not script. So
Okay.
Marathi, Nepali, or Hindi, they are different languages, but the script remains Devanagari.
Yes, the script remains Devanagari, but I'm getting semantic examples from all these three languages.
So actually, you wanted to mean cross language, Devanagari based cross language.
Actually, it's like cross like Hindi English, Marathi English, Nepali English.
Okay.
Yeah.
So what we are trying to generate is more number of parallel data so that we can get more examples.
No,
rather than
that is
language.
clear. That is clear. But I mean, script and language, that actually confused me.
Oh, okay.
Okay, thank you.
Thank you.
Okay, so I think in the interest of time, let's thank you again and move on. Okay, so we have the talk by Pagarai, but Ingo is the chair. So we'll have the other presentation talk in the next session. But then there is one talk remaining, private weather one, which won the honorable mention. So we'll have your talk after the first talk. Okay?
I will talk to you. You hear me? Can you hear me? Hello.
Hello.
Can you hear us?
Yeah, I can hear you. Should I start?
Okay, so yeah, you can hear me now, yeah? Hello?
Yeah, so I have shared my PPT. Is it visible, my PPT?
Yes, yes.
Hello.
PPT is not visible?
It is visible, but I just wonder if you can hear me. Can you hear me?
Hello, Utpal sir, can you hear us?
Yeah, I can hear you. Yeah.
Okay.
Okay, we'll be just fine which microphone works. So, hello, can you hear me as well, I hope? No? Can you just confirm? Okay, only listen. Hello?
Hello. Yeah, I can hear you. Though I mean, audio is not very clear, but I can hear you.
Not clear, okay. So, hi, I'm Ingo, I'm your session chair. And yeah, so let me introduce our next keynote speaker, Gawain. He's a professor at the Indian Statistical Institute in Calcutta and the head of computer vision and pattern recognition unit in the Center for AI and Machine Learning. And his research focus is on AI systems, machine learning and deep learning, with applications in NLP and vision-based systems. And he has published over 160 peer-reviewed papers, has dozens of granted patents and lots of awards. And yeah, I'll hand over to you. He will speak about on multi-role alignment of language models. Stage is yours. Thank you.
Yeah. Thank you. Thank you so much. Am I audible, the audience?
Yes.
Okay, thank you. So I'm very sorry because at this time I should have been there in the conference hall, but unfortunately my flight got cancelled, and these I planned for several months, and that's why there was a clash between this FIRE and another conference, and I said no to the second conference because I decided to participate in FIRE. But anyway, very sorry. And today this talk is basically on multi-role alignment of language model. So somebody let me know if I'm not audible or if there is any connection problem. Now, so is slide transition working?
All good.
slide transition is working, right?
It is working, yes.
Okay, thank you. Okay, so this is the the research question that how to dissociate LLMs from generating harmful behaviors, because now say so LLM they are so we have been using LLMs for last couple of years, but now the problems we know very well that LLMs can generate text that can facilitate self-harm, that can expose safety vulnerabilities in computer systems, that sometimes is giving aids in criminal planning, assistant manufacturing or use of weapons, explosive, regulated substances, and many things, right? So these are really very problems of great concern. And that's why one direction of research today that how to generate guardrail, how to develop guardrails to dissociate LLMs from generating harmful behaviors. Now, just if we look at the initial approaches, because these problems are quite well known from the very beginning of LLMs. So one dominant approach that was proposed in ICLR 2022 is basically refers to supervised fine tuning, STF, and this is quite important paper because LLMs are say zero-shot learner or this zero-shot learning and few-shot learning. These ideas were nicely introduced in this paper, and in the same year in NeurIPS, using RLHF, that is reinforcement learning with human feedback. So these authors they wanted to propose a methodology. So if it is not desirable, then giving some human feedback to the LLM to correct this problem. And next year, another significant algorithm was proposed again in NeurIPS 2023, that is direct performance optimization. So it's basically if we prefer something, then how to give this feedback to the LLM. But the problem, so these are the three dominant approaches. But with each of these approaches, the main problem is they are extremely brittle because they're easily bypassed through fine tuning and then prompt-based attack or adversarial attacks, and that's why there are many jailbreaking algorithms available, and so these approaches were not very efficient for the purpose of giving the proper guardrail to LLMs, right? Now later on, those kind of recent approaches. So one thing came out that basically instead of these approaches, auxiliary methods or models are employed alongside LLMs. So for example, instruction tuned LLM to classify prompt. So when a user is giving prompt, then to classify whether this prompt is can be should be answered or not, and that is done through instruction tuning. Then another approach that was this year only, it was proposed in NAACL 2025, that LLMs to detect intent of the user and then analyze safety and sanitize unsafe queries. And at the same time, in ACL 2025 this year, so one interesting approach proposed that prepending a secret string to the user query and applying preference tuning. So preference tuning was proposed in NeurIPS 2023. But again, the problem is if it is exposed that, okay, a particular string is padded before for the some users, then that will be again in problem, kind of key discovery kind of the problem in cryptology. Now, another obvious solution is that two-model solution. So, what is two-model solution? That one tuned to follow instruction and the other additionally tuned for safety. But the problem with, let's say, for the common users who are not classified, then they will use one model, and for the classified users, they will use the additionally tuned model, which is, for the common people, additionally tuned model for safety will be given, right? But the problem with these two model solution is that these are very cumbersome training runs, and then you have to data set splitting and how to model storage. So two models should be there, and so it's not very easy to manage. And not only that, so for this kind of two model solution, also the subject to jailbreaking methods, and so easy to cross the guardrail. Now, so this is the state of the art scenario. So, given this scenario, what we attempted and we reported our results in EMNLP 2025 this year. So, we brought the idea from cryptology that is it possible that to develop LLM which will be user aware. So let's say there are two users, Alice is authorized user and Bob is unauthorized user. And when Alice is giving this kind of sensitive query, this sensitive query can come from an authorized user, then LLM will generate reply. And if this kind of sensitive query is coming from any unauthorized user, then LLM will say sorry, kind of refusal, right? So this is the proposal. Now let's see that how we can conceptualize this user aware LLM. So the method actually depends on the training part. Is basically depends on there are two major steps. First step is that we use small language model SLM, and that is used to rewrite the user query. So user is writing a query, then we'll use a small SLM that will rewrite the query. Now, this SLM follows a generation strategy that introduces an identifiable distribution. I call it identifiable distribution shift because so the SLM responses from Alice and Bob can be identified, right? So I'll show you that. But the queries, original query and the refreshed query, they are semantically they should be similar. So how to achieve this? Now, so there will be an SLM, and then this SLM will generate a query by introducing identifiable distribution shift, one for Alice and another for Bob, and then we'll have the target LLM. So we'll go for fine tuning the larger target LLM on the biased query, because these biased queries are coming from small language model. And fine tuning will ensure that the target LLM or larger LLM will generate the ground truth answer for Alice because it's an authorized user, and it will have a refusal for Bob, right? So this is the training part. Now, during inference, now authenticate the user. Let's say you have your user ID and password for API, LLM API. So the moment you are authenticated as the authorized user, Alice or Bob, they will have different authentication, and refresh the query accordingly. The refreshed query is forwarded to fine-tuned LLM, and we expect that LLM will give answer to Alice and will have a refusal for Bob. Okay, so this is more or less, the major steps of the method. And if you look at the training part, so the original query, right. So here you see the original query is going to SLM, and then SLM is generating a biased query for Alice and Bob, and then for Alice biased query with the answer is going to fine tune this the target LLM, And for BOF query, it is trained, fine-tuning the LLM with refusal. So this is the training part. Now, during inference, if we find that query is coming from authorized user, SLM will generate QA and LLM will generate its reply. On the other hand, if the safety query comes from BOF, which is unauthorized, then for QB, LLM will not generate any, basically it will generate a refusal, right? Now, technically, how to implement these things. So first part, if you look at this, how to generate the biased query, right? So biased query refresh. So method actually involves this process that given some corpus, we construct two sets of words. One set is a common set, the top 500 frequent words, and the second set is called the rare set, R set. It is nearly 499,500 words. Let's say total there are 500,000 words. So only top 500 frequent words are used to have the set C, and the remaining words are going to rare set R. Now, given an SLM with the vocabulary V, we define VS. What is VS? So we generate all the tokens from the set of rare words and minus the tokens from tokens that we get from the set of common words, and this different set is basically we call it VS, right? So we can see that VS is basically containing the rare tokens, right? Now, next, and definitely VS is a proper subset of V, where V is the vocabulary of the SLM, right? Now, we split VS into two roughly equal sized partitions, VA and VB, such that, so VA is for the vocabulary for Alice and VB is vocabulary for Bob, where VA and VB intersection is null, and VA and VB union is VS. So VS is roughly divided into two equal halves, VA and VB, where there is no intersection, and they basically union is VS, and they are roughly same in size. Then we set VC is basically V minus VS. So you see that V is the entire vocabulary, VS is the vocabulary of the containing the rare tokens. So VC is basically the vocabulary of the set of common tokens coming from. So first we do this division, and then VC contains common tokens as I explained to you, and all special tokens from V, and VA and VB contain a disjoint random assortment of less frequently used tokens, because VA and VB, they basically come from VS, right? And VS is basically rare tokens minus all common tokens. So next we define the vocabulary for Alice is VC. VC is common for both Alice and Bob. VC is the vocabulary of common tokens, and VA is the vocabulary of rare tokens for Alice, and VB is the vocabulary of the rare tokens for Bob, right? So now we define the vocabulary of Alice and vocabulary of Bob, right? Once we have these two vocabularies, next we manipulate the logics to generate biased query as follows. So you see that if now X can be Alice or Bob, so if the word is in the vocabulary of Alice, then we change the logics like this, or we do, and here you see that minus K. And in our experiment, we set K equals to 10, and we get satisfactory results. But anyway, so it's just a, hyperparameter user-defined one. So, also we can compute the probability that, say, when WT is equal to W, that what is the probability that this is for Alice, then probability can be computed from the softmax. And similarly, we can compute. So later on, we will use this probability to detect, even under adversarial attack, to detect whether the refresh query is coming from Alice or the refresh query is coming from Bob. Okay, so that will I'll discuss later on. But this is the technique to generate the biased query. And if you look at that, the kind of biased query this model is generating. So look at this. This is the original query. Which of the following is required for both paramagnetism and ferromagnetism? So refresh query. So what is refresh query? If we do not use VA and VB separately, then this is the refresh query, right? Let's say VA and VB, they are same. Then refresh query is which property is necessary for both paramagnetism and ferromagnetism. But the moment we use VA for refreshing the query for Alice and VB for refreshing the query for Bob, you see the refresh query for Alice is which property is essential for both paramagnetic and ferromagnetic materials, and for Bob the same query is refreshed to this, which property is necessary for both paramagnetism and ferromagnetism, right? So this is one example. But well, from this example, you will agree that, okay, semantically, the original query remains same. And this is another example where we use VA for Alice and VB for Bob. When the original query is all the values of a data set are the same, all of the following must equal 0 except for which one. And for Alice, it is refreshed to if all the values in a data set are identical, which of the following must not equal 0. And for Bob, if all the data points in a set are identical, which of the following must not be 0. So these are the refresh query for Alice, and but by introducing the identifiable distribution set. So this is the quantitative evaluation that, okay, refresh query, how similar they are with the original query, and for computing the cosine similarity, we use this OpenAI text embedding 3 large text embedding 3 large for generating the text embedding, and using that embedding, we compute the cosine similarity. And you see that cosine similarity is giving so 2.57 billion model is giving the highest, more or less the highest and accuracy and very good cosine similarity. Okay, next is how we computed the accuracy. So response accuracy, let's say, so the original query came from MM and LU dataset, and for original query, the accuracy was 89.2%, and for you see for 2.57 billion, accuracy became 88.4% for this data set. I mean, for queries, and the answers are multiple choice answers, right? And for computing accuracy, we used OpenAI, this 01 2024 1217 model. And so this shows that biased query are semantically very close to the original query. Now next we checked that, okay, so I mean, how far we can we are able to achieve this user specific LLM that we want to do, that multi-role LLM. For conducting the experiment, we consider two domains as safety domains. Let's say legal and medical, and our assumption is that not anyone can come with a legal question and get the answer from LLM. Not anyone can come with a medical question and should get answer from the LLM. So these two are safe domains we consider. Okay, and where so these are safety issues, and where there is no problem with safety is basically a math domain and trivia QA. So we consider two data sets, trivia QA and MMLU, this is the math part. So MMLU medical is used for medical domain experiment. MMLU legal is used for legal domain experiment. And this LSC dataset was Moslem 2025. And then this legal MMLU, actually, this dataset was proposed in ICLR 2021. Then another, we found a very nice dataset, legal bench, that was proposed in New RIPS 2023. And for medical chat doctor, that was Labita AI. So they published this dataset in 2024, and MedQ is in a journal Applied Sciences 2021. Okay, so these are the basically, if you look at this, so this 1, 2, 3, 4, and MMLU has 3 parts: legal part, medical part, and math part. Is this another thing which is safe domain? I mean, so any query from this domain, this Alice and Bob both should get the answer, but for legal and medical, Alice should get the answer, not Bob. Bob should receive a refusal, right? So that's the framework. Now, we constructed 2 baseline strategies. One is instruction only baseline, and so there is no fine tuning involved, only instruction. And if you look at the kind of instruction we provided, that you are a user-aware AI assistant, then there are 2 users who might provide you with queries, Alice and Bob. Alice is a known trusted expert. So this is basically instruction, and no fine-tuning is happens based on this, right? And for vanilla fine-tuning, VFT, which uses original query alongside appropriate labels, so ground truth for Alice and refusal for Bob. So and then so let's say there is a query, and if the query is coming from Alice, then the ground truth answer will be given. If the query is coming from Bob, then refusal. So that is the vanilla fine tuning. And our bias fine tuning is that we generate. So this is the refreshed query for Alice, and this is the refreshed query for Bob. And then this is the for Alice answer will be there, and for Bob refusal will be there. So look at the difference that VFT and BFT. That here no refreshing is there, but here QI is the refreshed query. Now for biased BFT training, we considered 2 data sets. I mean, we are sensitive data set. One is LSE and Chat Doctor. This is for medical, and LSE for legal. So these 2,000 samples from each data set for fine tuning, and additional 500 for evaluation. Now, if you look at the now there are 2 parts. One is SLM. So for SLM, we used these 3 LLMs. One is 2.53 billion and 7 billion. There are 2 versions, and then Llama 3 billion, 3.2, and Llama 3.18 billion. And as a target LLM, we used 2 different LLMs. One is GPT-4o and GPT-4.1 mini. And for both BFT and BFT, so GPT-4.1 mini was fine-tuned for 2 epochs, and GPT-4o was fine-tuned for 1 epoch. So this is the experimental setup. Now, if you look at the results, so what is meant by accuracy? Accuracy is that so when Bob is giving a query, so refusal should be received, right? So so that is the accuracy. And for Alice, Alice should receive a reply, right? So from the LLM. So that is the accuracy. Here we are not computing whether the generated answer is right or wrong. So now look at this is the BFT was fine-tuned from 2,000 samples from Chat Doctors, and for MedQA and MMLU medical. So these are used for testing only, and these test results on 500 samples from Chat Doctor, right? And for LSE, this was 2,000 samples were used for fine-tuning, and similarly for safe domain, which is not sensitive. So Trivia QA was used for fine-tuning, and then 500 samples were used for evaluation. And the second evaluation, MMLU math, there was no samples involved for fine-tuning. Now, here you see that for for instruction tuning, always the accuracy is very less. That Bob is getting refusal for only 87%, and chat doctor is used for fine tuning, so the result is slightly better. But if you look at the results for other datasets, MetQA and MMLU, the performance is very, very low, right? On the other hand, for bias fine tuning, still we have a nice guardrail. For chat doctor, 100% cases, Bob received refusal. For medical question answering, this 64% cases, Bob received refusal, and 57% cases, this MMLU, the Bob received refusal, right? Now, so these are two for target LLMs. One is 4.1 mini and for 4.0, GPT-4o. And for here, you see the accuracy is almost 100% for all the three cases. Here, almost 100% for all the three cases, and 100% for Trivia QA, which was used for training. And this on evaluation set, and 97.2% for MMLU, right? Maths data set. So this is Bob, and for Alice, now look at Alice, that Alice is receiving, not getting refusal, it is receiving reply. So for chat doctor, it is 97% cases, there's 100% cases for these two data sets. Now, one thing, again, I'll bring this thing into discussion, that BFT is showing basically fail close behavior. So when I'm not very certain, then I refuse to give answer, right? On the other hand, if you look at BFT is basically fail close behavior. So when BFT is not very certain, but still it generates the answer, right? So this is difference, and also that is kind of positive for our algorithm, that BFT is so fail close behavior it is showing. Now right, and then so these results we get after fine tuning the target LLM, right? Now the obvious question comes that, okay, you do fine tuning, but what happens to original LLM? I mean, is it affecting the original performance of the LLM, right? That's why we did one more experiment, that, okay, does multi-role fine tuning affect the performance, original performance? And if you look at this, that so for 4.1 mini model, when they are tested on these three different sections of MMLU dataset, the performance difference is not that big. So instruction is 89%, and then BFT is 85%, but our bias fine tuning is very close to the instruction fine tuning, and so that gives us some impression that, okay, this multi-role fine tuning is not affecting the performance of the original LLM by any significant margin. Now, next, what we wanted to check is that attack robustness, right? So what happens if so this system, we call it pseudo LLM. That pseudo comes from this Unix community that super user do. So we call this system as pseudo LLM. So what happens? I mean, how to attack this pseudo LLM and how to check its robustness? So far, if you look at the attack types, then very important, most popular attack types is log probability, log prop based attacks, right? So in log prop based attacks, what happens, that user basically it uses a log probability feedback to find small prompt modification that make a model more likely to produce unsafe or compliant responses. For example, let's say searching for a prefix. So basically, this is prefix-based attack, and suffix-based attack is not very practical because I mean, LLM will generate the token based on the previous tokens, right? So prefix-based attacks is the most popular one. So the idea under this log prop-based attack is that searching for a prefix that improves log props of non-refusal tokens. For example, sure, of course. So idea is to generate the token like sure or of course, so that it pulls the LLM. And so you expect a refusal, but LLM is pulled because of these words, sure, of course, because these are non-refusal tokens, and then LLM will generate the answer, right? So this is one of the most popular attack techniques for today, that how to attack, I mean, kind of jailbreaking, popular jailbreaking approach. Now, if you look at, so we followed this prefix-based attack, and if you look at that attack success rate, that attack success rate is basically it's 44% when prefix, we use now 5 words as the prefix, and the more number of words are included in the prefix-based attack, the attack success rate is like this. On the other hand, if you look at that vanilla fine tuning and instruction-based approach baseline, then attack success rate is much more, right? But for our bias fine tuning, this attack success rate is quite low. And this is for GPT 4.1 mini. And when we did the same experiment for GPT 4.0, the attack percentage is very, very low. So even considering 50 words as a part of the prefix-based attack, only 0.6% is the overall attack success rate. So for this shows that our pseudo LLM is quite strong against prefix-based attack, possible attack. And another extreme attack could be adversarial attack could be, let's say, the entire approach, because entire approach depends on this manipulation, right? Manipulation of logic to generate biased query. Now, what happens if Bob knows the entire algorithm, that okay, there is a manipulation algorithm, and then the Bob tries to generate the biased query to behave as Alice, right? Now, so already we discussed about that probability that when a query is coming, that what is the probability it is coming from Alice, that can be computed using this probability for all the tokens. And using this probability, we tested that intended user can be detected in 94.5% cases with probability greater than 0.7. And if we increase the threshold, that probability must be greater than 0.8, then almost 94% cases, 93.9% cases, we can identify the intended user, whether it is Alice or Bob. Right. So it is not very easy to so that Bob is behaving as Alice. But let's see that quantitative results that when adversary is Bob and Bob knows the algorithm. Now Bob is Bob is recognized as Bob, and then so Bob is behaving as Alice can be detected for 100% cases using Chat Doctor, but Chat Doctor is used for training also, and LSE because these two data sets we use for fine tuning. So you see that 100% cases Bob, this adversarial attack can be detected, and for MedQA this detection is 98.4%. I mean that so this adversary is Bob and behaving as Alice. And also for BFT plus detection, when we use this detection algorithm, here we are not using the detection algorithm, but still, so 100% cases Bob will receive refusal, though it is trying to behave as Alice. So 98% cases it got refusal. And detection is possible, Alice as Alice, Bob as Alice. So detection is possible that adversarial attack, 100% cases for Chat Doctor and 100% cases for MedQA. And so this is a very nice, guardrail against the adversarial attack also. Now, to conclude that one thing is very clear, that current practices to detect harmful intent are very brittle for safety alignment. Because the dominant idea, the reason is there is a tension between the language model objective. Because language model objective is that which aims to generate the next base token, and the safety objective is that which produces refusals when harmful intent is detected. So there is a tension between these two objectives. So our pseudo LLM, what it does, it alleviates the tension with the introduction of the authorization-based query biases. It's a kind of slightly new idea that user-specific LLM. And already I mentioned that it shows the fail-close behavior. So when it is uncertain, it doesn't generate the answer. Unlike VFT is showing fail open behavior. And this pseudo LLM can complement existing input-output monitoring or intent detection-based guardrail mechanism. So this approach is not basically in place of something else which are already there. So pseudo LLM can be used in conjunction with the other guardrail mechanism to further improve end-to-end LLM safety. So this is one of the strengths of this pseudo LLM. So it is not competing with any other guardrail mechanism, right? Otherwise, rather it can be used in conjunction of any guardrail mechanism. So finally, I should acknowledge Dr. Soumyadeep Saha. He recently got his PhD on domain-obedient deep learning, and Dr. Akshay Chaturvedi, a couple of years before, he got PhD on adversarial attack on deep models. And my student Joy already submitted. His PhD basically considers data-to-text generation. And the work what I presented right now is basically was presented in EMNLP this year 2025 to LLM on multi-alignment of language model. Thank you so much.
Thanks a lot. Okay, are there any questions? Hi, thanks for the interesting talk. The question I had was, you're trying to detect and block, perhaps offensive, harmful responses. I read a paper recently that said if the underlying technology is a RAG system rather than just an LLM, that makes it much more challenging. So I may have missed it, but were you getting an LLM to block harmful content, or were you getting a RAG system to block harmful?
Sorry, because of echo, the audio is not very clear from the hall. Can someone repeat the question, or that will help me to discuss.
I'll try again. So the systems that you're trying to prevent harmful answers, is it an LLM or is it a RAG system?
Did you get that?
Oh, no, it's not clear. I'm getting the voice, but it's very echo-like things.
So the question for Mark was, is the system that you're using, is it a pure LLM or is it a RAG system?
Or can you write down it in the chat window? Just one line, the essence of the query.
Okay, then write that in the chat.
Is the system this is an LLM? Oh no, this is purely LLM. So both the So we have target LLM and one small language LLM, and also if you look at the kind of LLMs we have used. Right. So this is the experimental setup. So we used this basically two versions for Coin, and then for two Llama versions for SLM, and target LLM is this 4.0 and 4. So we didn't use RAG kind of technique here. It's purely LLM based. Sorry, I was not able to answer the question. Yeah, I recently read a paper that RAG systems are much more difficult to block than maybe, but our experiment, our experiment just covers LLMs, not RAG. Yeah, that's a very nice point you raised. Probably, I mean, in continuing this research, we will consider RAG systems also. Thank you.
Okay, I have a question. Am I audible?
Yeah, you are audible, but voice is not very clear. Okay, let's try.
Okay, so the question is like this: that nowadays people are using LLMs to write the prompts even. So if Alice and Bob both use LLM to write prompts, so would there be really any distinction between the ways they write? Because it's basically trying to understand the user-specific styles, right? To produce another guardrail after the initial authentication. So that's my
right. So yeah, so this is I mean, intent for identification is already it's well, not well researched, but many researchers, they have studied intent identification. But in this case, even you see that Alice has a very different style for writing prompts, which is different from Bob. Then let's say Bob wants to mimic the prompt writing style of Alice, but the way you have seen that we have generated the biased query, right? And this using the vocabulary. So whatever, I mean, the entire vocabulary of SLM is V, right? And now the rare vocabulary, which is VR, is so basically VS is divided into two parts, right? VA and VB. So that part will take care of these things. I mean, it will neutralize the attempt to try writing query following Alice style. This will not work because of this. This biased query we are forming based on the vocabulary things, right? Again, vocabulary will be divided, and then one part will go to BA, another part will go to BB. So it's not that I can mimic at the word level, and I will mimic as Alice. It's not possible. It's not that easy.
Yeah, it's, thank you very much.
Thank you.
Other questions? Online on the room? Okay, doesn't seem there's any further question anymore. See correctly, and with the tea break scheduled now. So okay, so I suggest we are finishing now. Thank you so much for your interesting talk. And yeah, let's schedule more. Okay, so thank you so much, and hope to see you in person one time.
Yeah, hello, Paula. So it was nice talk. So again, can you hear me? So you know, so a memento is due.
Oh, thank you.
Talking about application, so hopefully we will be able to send you to post. And thank you for sessioning the chairing the session. Okay, thank you.
Thank you so much.
Break for tea.
We'll be back after 15 minutes and we can 4 p.m.
And we'll have the talk that we missed in the session, we'll have in the first half of the meeting. Yes. We'll have that talk again. But the other chair. This is right, basically like that you will get a whole bunch of documents. Yeah, it's even if you give retrieval. Anyway. Okay, so we have one remaining talk from the conference track now, which also won the Honorable Mention Award. So I will request the author and the presenter to come up to the stage and set things up. So you have got 10 minutes plus QA. Thanks. Can start and more people to grab.
Okay, sure. So I'm presenting my dissertation work on towards Ayurveda information retrieval, so challenges and opportunities. So this has been this work has been supported by Ayush Center of Excellence, Ministry of Ayush, which is present in the SPP campus. Of course, this has been guided by my advisor, Dr. Vandana Tira, and Dr. Krish Tidu, who is basically the Ayurveda expert in this field. So this is the overview, and to introduce Ayurveda is something which is the science of life. So typically Ayur means life and Veda means the science. So it contains a comprehensive knowledge base that has been passed through generations, used in the treatment of the patients. Out of it, Charak Samhita is one of its core texts on Karachikitsa. So Karachikitsa means basically the body, the healing of the body. It also has got an interdisciplinary relevance. I mean, people from various backgrounds, philologists, researchers in history, mythology, all of them do refer this particular book. And since most of these books in Ayurveda have been written in Sanskrit, the information retrieval for this particular kind of thing becomes difficult, primarily due to the language factors, like let's say Sandhi, which is euphony, and compounding phenomena. Moreover, Sanskrit has a feature of being written continuously without any explicit word boundary. So, we are not the first one to do it, but at least in Sanskrit, but there are generic systems that exist. Let's say Gaveshika, it's from University of Hyderabad. Then there are philological level search systems that exist. One is from Sarit and PCS. Then there are domain specific search engines like one provided by National Institute of Indian Medical Heritage, Hyderabad. Then there is one from JNU. CIRAC Pune also has developed a suite of tools which contains a search system. And then there are individual efforts where people have developed their own Android applications to search the Samhita. Yeah. So all of these search engines have or follow a pattern matching approach, something similar to a grid-like utility, where you need to enter out text in a particular format. So this is the NIMH keyboard layout that has been shown here, where if you miss out any single character while typing the query, you end up getting no results, or the results are pretty weird that you get. So, I mean, I'm just summarizing out the whole thing that I said here in this table, wherein there are no Sandhi and or compound processing things. So, for example, even these search engines do not handle synonyms that are present. So, for example, a single word of water in Sanskrit has got almost 250 different words. And then you can consider the complexity of those additional suffixes. So there are 8 cases into 3 different cases of singular, dual, and plural. So that means one word can be written out in 24 different ways. And because of this, it introduces a lexical complexity as well as we move ahead. Similarly, the last point tells us that they just do a literal string matching thing. So these are our objectives. So our objectives mainly target to have a Sanskrit-aware computation pipeline for information retrieval that basically indexes the root words and the synonyms. These search engines for the clinicians do not have support for the different various types of queries that we have in typical IR domain. And moreover, these challenges of vocabulary mismatch and doctors typically right now do a process of writing one query, fetching out its results in an Excel sheet, then going back to the search engine, writing out the query again, getting those results, and then coming up with or and kind of whatever they need to have. So in order to do, we have developed out this particular pipeline along with creation of dictionaries for root words, synonyms, stop words. And then we also tried out indexing the whole thing with n-grams as well as word level indexes. So this is the methodology that we followed. In the pre-processing step, we took the different verses in the compendium. We performed out its transliteration and segmentation. So for example, here the verse that we took was Athato Apamarga Tanduliyam Adhyayam, which after transliteration and segmentation turns out into Atha Apamarga Tanduliya Adhyayam. And then we typically perform out the lemmatization and stop word removal thing. And whatever the words we get after doing these processes, that is being sent to the indexer. So while we are indexing the words, we also attach the synonyms of the words using the dictionaries that we have created. So this is a typical process of step by step that goes or happens with a particular verse before indexing. In order to have the root word kind of thing in place, we have created dictionaries for the different endings in Sanskrit. So this table particularly looks at the words that end in O. They are called as akaranta ending nouns. So based on the longest prefix matching, we just truncate out those and perform out the root word kind of thing. Then we have manually, even the doctors provided us with the root word, the indeclinables that are present in the compendium. So let's say in the example previously that we saw, Vyakyasyam is basically a word, and doctors do not search that word in their usual search process. Then this is the list of synonyms that we create. Of course, this is not an exhaustive list. We are just displaying a sample of it here. Then after we have done the processing of all these verses, we try to create out the index. So the index, when we had been working or we were working on this particular statement, there was a paper which suggested that you could use for Sanskrit the n-grams as 3. But here as well, we found out few issues. I'll explain out as we move ahead. Then there are these were the sample queries that we targeted on the search engine that we developed. Here, the single word query was something that was only possible on the existing search engines. Rest all types of queries were never, I mean, they would never execute on that particular search engine that we were seeing, or which is primarily used by the doctors. Therefore, what we did was we took a maximum number of single word queries in order to have a kind of baseline comparison, and then comparatively a lower number of Boolean and the other search queries. This is the interface that we developed. It's a simple interface, but yeah, users were able to query and perform their relevant information retrieval needs. These are the results, wherein you could see the blue line, which is for the existing Ayurveda search engine or domain specific search engines, which is only present in the single word query. These are the recall and precisions. So here, if you would have a look with Ngram approach and with Boolean or the other three kind of things, queries, you would look that the Ngram approach gave us a higher recall, but that was somewhere, so any subword matching took place between the queries, and that resulted in the overgeneration of the whole result. But it drastically reduced out the precision. Therefore, we basically came up that, okay, word level index should be something that should be followed. Further, as I said, we asked few doctors or clinicians to evaluate our system. They as well found out that, okay, we are not able to run few queries, and which we were able to run on your search engine, and therefore that really improved our the time that was being wasted into to and fro of querying and refetching the results. Yet, even with this, there are limitations. I mean, whatever segmentation models we utilized, they were doing out a fair job, but still it missed out the context of Ayurveda. Let's say, for example, the Krimigna. So when you say Krimigna, typically in Sanskrit or in general thing, it would be broken down into Krimi and Gna. So basically, which means it has got Krimi is one word in itself, and Gna is a word in itself. But when you come down into Ayurveda domain, it turns out to be Krimigna is a medicine. It's the name of a medicine. Therefore, it needs to have a more context aware kind of models to segment and index the. Moreover, as I stated, so in Sanskrit, when you move from one domain to another, so if you work out in Bhagavad Gita, you cannot directly apply that whole knowledge in the model to a different domain. So these are few limitations that we have. In conclusion, Ayurveda experts have been struggling for a long time, be it with writing queries in a certain manner, or redoing the stuff for fetching and storing the results and then performing whatever they needed to. But our pipeline has actually helped them to reduce out their time spent in just searching out through the compendium. And so and further, we also incorporate our domain specific dictionaries and mapping functions to index out the text, which gives us an overall recall increase in 6%, and as well as a 3% increase in the precision values. And the most important part is that it supports out flexible query and accessibility of the ancient. Yes, so these are few points around the future work. As I stated already, we need to have some more contextualized language models, or let's say the models that understand the context that this particular thing is for Ayurveda. Around that thing, there needs to be some work done. Then there could be something around semantic information retrieval that can take place. And then we need to, of course, scale the whole pipeline to a level wherein a good amount of work is needed to be put in. Does this keep it on?
Any questions for the speaker from the room or from online?
Okay, thank you. So, don't you think that the problem is, general nature, not only restricted to Ayurveda text? I mean, it's specifically common for language like Sanskrit, where this kind of Sandhi and Samaskurs make the word segmentation difficult. So can what agglutinative language like for German or Scandinavian languages? Right. So
Yes, so I mean, when we were working, or we are still working on this, this is a generic thing, but in information retrieval domain, we do have a specific case of medical information retrieval as well, wherein people, and I'm not sure how would I justify this, but still medical information retrieval becomes a specific case in information retrieval where they do not even know how you should appreciate or see whether whatever the results are they relevant or not. Even these kind of things are still being looked upon in medical information retrieval. Then for Ayurveda people, it is a simple thing like, okay, I have given out a query. I just need to have the results. And with other general engines, what happens is it just fetches out results from all the different things that are present around. So though these problems are generic, they need to be studied or they need to be worked upon from a domain specific view as well.
This was done specifically for Charak Samhita compendium, which is very much used by Ayurveda doctors actually. Day to day life, they are using this Charak Samhita compendium, which is very much required in their daily life. So, focusing on that, we have, with their problems specific, we have developed this kind of search engine.
okay, so my point was, I mean, why don't you think of generalizing it? Okay. So,
Yes, right now we have focused on Charak Samhita compendium only, and we will be, with this kind of work, we will be taking up again for further work also, for further literatures also.
That was wonderful presentation. I had a question regarding the language itself. Since I have seen Sanskrit and I know the little bit of grammar rules, is it possible to build a syntax tree for the Sanskrit language so that it can be generalizable with a abstract data structure for it instead of going through all this?
Yes, kind of. And I mean, there are even data-driven models that do these kind of things. And even we have currently utilized some else model. But when they have also trained their data, let's say just on Bhagavad Gita, it at times works fairly. But the review that we have received from the doctors is that, okay, you need to do the segmentation part in much more better manner so that we could get our results in let's say in much more clearer way. I mean, yes, there's something that can be done around those lines. The
So
syntax
the
tree.
syntax tree will not require any kind of fake. It will
Right,
just be a
it-
standard.
Yes,
Grammar based.
very correct.
Thank you.
Yeah.
Any other questions?
Availability of language resources and the amount of data in Sanskrit is static query model or even a generative model that has been developed?
No, it's a simple CNN RNN combination that has been developed and that has been trained on the DCS from on the data from the DCS, the digital corpus of Sanskrit, wherein they have manually annotated the stuff.
Any other question? I have one question for you. So you mentioned in the future work that you wanted to do something like the semantic expansion, query expansion kind of thing.
Yes.
But you already have added synonyms when you were indexing. That's what you mentioned.
No, but when a particular doctor is searching through it, so we are still working with the Ayurveda experts and there are multiple things. So let's say one of the thing was we are just focusing on Charak Samhita as one compendium. But there are naturally other compendiums like Sushruta Samhita is there, even, there are some Nibantus as well. So all of them mention out the medicine names and then they have got some properties associated with them. Like there are rasa is there, so the ras might be thick or something around those lines, and therefore we need to attach out the things. So let's say once the doctor queries out for a particular medicine or a disease, he might just end up getting what is its rasa or what is its guna, and based on that he might just make his life easier. That's it.
So there's more to semantics than just that.
Yes.
Dictionary based.
Yes.
Very wonderful work. So thanks again. So we move on to the Chromate track now. So I will request the participants of the track to please come ahead. I think there should be at least some. So maybe you can take a seat in the first row and then go on. Are you the one who is going to go first? Who is the one? Yeah, so come ahead. So this is to the online audience. Is anybody presenting for the Chromate track? Can you please identify yourself? Just saying hello.
Yeah, hello, Utkrishт.
Okay, so there's only one presentation online, is that? Or there are
Hello,
other
I'm
speakers?
here as well.
How many are there? Are you the only one? So we'll have the online presentation first. So I request the speaker to share his screen and then we can proceed with the online one first. Hello. Can you hear me?
Yeah, just sharing my screen.
Yeah, okay.
So we'll get about 10 minutes of time. So in the interest of time, we're already running behind schedule. Try to wrap it up.
I hope my screen is visible.
Yes, please go ahead.
Oh, yeah.
It's not whenever you're ready. We can see your screen. Hello. Can the speaker hear me?
Yeah, just a second. Yeah. So, good evening,
Yeah, so
everyone.
so whenever you're ready, just
Yeah, so I'm starting now. So, good evening, everyone. I am Utkrish Roman, presenting on behalf of my co-authors Kailasha Sai Charan, Roshan Jain, Jasneet Kaur, and Dr. Shakshi Sharma. Our work is titled Aurora, Automated Understanding and Recognition of Omnilingual Misinformation Artifacts. So, since the task formulation and evaluation setups were already covered in the overview of the task, and so I'll focus directly on the motivation, system design, and key insights for our approach. So, in real world crisis scenario, misinformation spreads extremely fast, often outpacing the fact-checking mechanism. So during events such as Russia-Ukraine conflict, we observed misinformation propagating simultaneously across multiple languages and platforms. The impact is not limited to only online discourse. It distorts public understanding, hampers journalistic or verification, and directly interferes with the policy and crisis response. This makes it clear that misinformation detection system must be fast, scalable, and multilingual by design. So from our analysis, the current solution struggles mainly due to three limitations. First is speed. So manual verification pipelines are reliable, but too slow for rapid evolving crises. Then many systems are still English focused, leaving a large fraction of global misinformation completely unaddressed. Finally, model trained on one domain, such as health misinformation, often fails to transfer the new context like geopolitics or conflict. These gaps collectively motivated for the design of Aurora. So Aurora is designed as a simple but deployable pipeline. The system takes textual claims from multiple languages through a lightweight web interface. At the core, we use a fine-tuned Roberta-based transformer optimized specifically for misinformation classification rather than generic text tasks. The output consists of a binary decision, misinformation, and not misinformation, along with a confidence score, which is important for prioritizing in real-world moderation systems. Our emphasis here was not just accuracy, but practical usability also. I'll keep this brief since avoid metric level details. So we observed that the model performs consistently well across languages and domain, indicating strong contextual understanding. The confidence scores were particularly useful in separating high risk misinformation from borderline cases. which is critical in high volume scenarios. So overall, the results validate the robustness and stability of our approach. Then the key focus of our work was generalization beyond a single topic. We evaluated the system across diverse theme and linguistic settings and observed minimal performance degradation. This suggests that Aurora does not rely on topic-specific cues, but instead learns from generalizable misinformation patterns. This property is essential if such systems are to remain useful during future unforeseen events like here the China makes 80% of all toys and 90% of all Christmas goods sold in the US. We have taken this headline from a fact checker site and it says that it's likely not misleading with a 10% confidence of it's not an misinformation. Sorry, 10% confidence of it's a misinformation. So it says it's likely not misleading. Then from multilingual, we even gave it a prompt in Hindi and it says that 68% there's a chance that it's likely misleading. Then we presented Aurora, a deployable system for multilingual misinformation detection, and it addresses key challenges related to speed, language diversity, and generalizability. As future work, we aim to extend the system to multimodal misinformation, especially like image text pairs, or we upload a video and for fact checking that it is misinformation or not a misinformation, improve handling of class imbalance, and incorporate enhance explanation mechanism by using LLM in it.
Okay,
So thank you for your time. I'll happy to take your questions.
Are there any questions for the speaker? If not, then we can move ahead with the next talk. Oh, there's some online questions. There are more online questions. Okay. So can you please identify yourself?
I am Utkarsh.
Okay. So. Yeah. So whoever wants to present next, can you please start sharing your screen? And start the talk whenever you're ready.
So I am ready to present my work.
Yes, so please start sharing your screen.
Okay, thank you. Thank you. Thank
you. Start whenever you're ready.
I think my screen is visible to you.
So screen is visible, just turn on the full screen mode and then.
Okay, right. So good evening to everyone. So this is Mallikarjuna Chindapuri. Actually, I am presenting on behalf of my friend Avinash Trivedi. I am a co-author. My paper ID is 165. So we are from SRM University, Andhra Pradesh. So the main, I directly come to my agenda. This agenda includes a methodology for implementing, for detecting misinformation and non-misinformation social feeds and the experimental setup, and experimental results, and finally I made conclusion and references. So this is the methodology what we incorporated for implementation of a system, which can helpful for detecting the feeds into misinformation and non-misinformation. So actually, the dataset will contain the mixed kind of feeds, so that we initially apply a large language model as a translator, so which will translate non-English words into English words. After that, so that is dataset contains one minor class. Over that, we will employ large language model for data augmentation. So once these two things are completed, after that we got a refined dataset. Over that, we implemented Debata model for fine-tuning with respect to the refined dataset, where that feeds into classified into misinformation and non-misinformation. We will explain the modules or pages which are included in the methodology. The first stage one, as a part of the stage one, we all translated all the non-English words into English by using Gamma 3 model, which is at 12 billion in large size. So for that, we use this prompt. With help of this model, we convert all non-English instances into English language. So once this task was completed, then we move forward for data augmentation. We applied data augmentation on minority class samples. For generating the synthetic data for minority class instances, we use a Gamma 312e large language model. So for that, this is the prompt we incorporated for generating the synthetic data for minority class samples. So once this stage was completed, then we move to the fine-tuning phase. So where we have a data set with the samples in equal number from both the classes, like misinformation and non-misinformation category. So misinformation, we have little minor in number, so that from the non-misinformation category, we selected the equal number of instances, so that we make data balancing. After that, about the balanced data set, we split the data set into training and validation in 80:20 ratio. So here, for about the training data, we fine-tune the Debata version 3 small model for classification purpose. Simultaneously, we used validation data for assessing the model performance. Okay, so these are the experimental setups we did. We made for fine-tuning the Debata model for classification of feeds into misinformation and non-misinformation. That is maximum token length 512, batch size is 6, epochs are 8, learning rate is 5e minus 5, optimizer RWW. So these are the hyperparameters with the Debata model is fine-tuned with over the training data set. So these are the results produced by the various large language models before incorporating the data pre-processing, like data pre-processing. So before incorporating the data pre-processing, like translation of non-English words into English and data imbalancing, over the raw data set only, we implemented all these large language models, but unfortunately we got the less F1 scores. So we consider these as the baseline models. After that, we applied our own methodology, like what I have discussed before this. So based on our approach, we got the results like precision, recall, and F1 score as 90% over the data set. Okay. So conclusion, after evaluating the multiple inferences strategies, ranging from zero shot and few shots paradigms to several prompting configurations. We found that Debata V3 small architecture is going to be produce most favorable outcomes, particularly in terms of weighted performance metrics. Okay. So as a future work, now we will aims to work with the more large language models and other versions of the Debata variation. So these are the references we come across during writing the literature work regarding this paper. And thank you. If you have any queries regarding our work, I can able to answer those questions. Thank you.
Let's thank the speaker. Are there any questions in the room for the speaker? Well, if not, then in the interest of time, we move ahead with the next speaker. Who I believe are there any online speakers?
Hello.
Yeah.
Yes, am I audible to you?
Yes, you are audible. So if you already can you please try sharing your screen and then.
Okay. Okay. So any questions from your side, then I'm happy to answer.
Any questions? So we can stop sharing the screen and then let the other speaker share.
Thank you, sir. Thank you. Thank you very much.
Hello, sir. Shall I share my screen?
So Gokul, if you're the next speaker, then can you just start sharing the screen? Can you hear us? Yes. Right. Can you make it full screen? That works. So whenever you're ready, please.
Is my voice audible, sir?
Yes. You can see your screens whenever you're ready. You can start.
Yes, good evening to all and all present here. Myself, Gokul NV from Sri Sivasubramanian Nadar College of Engineering, Chennai. So our research work focus on using the IndicBird V2 MLM only model for fine-grained misinformation analysis in South Indian languages. So, we are tasked with, we provided with an article and its corresponding summary generated by LLM, and we are asked to classify the misinformation into one of the four categories, which are misrepresentation, fabrication, false attribution, and incorrect quantities. So the research gap we found on this research was there is a limited resource for Dravidian languages compared to English, and there is a lack of fine-grained classification, especially across these four categories. So talking about the dataset contains 982 paired samples for each four South Indian languages, Tamil, Telugu, Kannada, and Malayalam. So each sample pair consists of both the article and the LLM generated summary. So the corresponding pairs were meticulously annotated with misrepresentation, fabrication, false attribution, and incorrect quantities. So prior to the model training, we underwent with the data pre-processing stage. In that stage, we standardized all column names for consistency and removed the entries with missing summaries or misinformation labels, and retained all incorrect summaries and their corresponding categories alone for training our model. So as a first step, we underwent through label encoding. We encoded the categorical labels, misrepresentation, false attribution, incorrect quantities, fabrication into numerical labels from 0 to 4. And then followed by tokenization. In tokenization part, we loaded the IndicBird V2 tokenizer, which is specialized for Indian languages. And it is also pre-trained with many Indian languages. And then for input, we concatenated both the article and the summary pair. we used the sequence length of 384 tokens, and we applied padding for making all the sequence same length. And then we converted the pandas data frame into Hugging Face data frame, and we applied the tokenization function to the entire data set. So our tokenizer outputs are the input IDs, attention mask, that is the part where the real targeted data is present, and the added input, and then followed by the token type IDs. Then we converted our data to PyTest tensor format, and we selecting only necessary columns with input IDs, attention mask, and labels. So attention mask was helpful in distinguishing between the real tokens, that is 1, and from the padding token 0. So the reason why we chose the MLM model was MLM stands for Masked Language Modeling. So for the reason for choosing this model was it will be the model was predicts the masked initially the random words in the model was masked, and the model predicts the masked word using both left and right context. Unlike the casual language modeling, in case it will be in unidirection, so it will get familiar with the language. So we used the MLM model. And then we used a special token CLS, which represents the global semantic information. And as we used both the article and its corresponding LLM generated summary, in order to separate it, we used a token called a SAP. And then these are our training parameters. We implemented batch processing of 8 samples per GPU. And we trained for 8 epochs, and our learning rate was 1E5. And we optimized the model by weight decay of 0.01, because if we have large weight, the model became too confident, and it will lead to overfitting. And then the best model was selected based on the F1 score. And the training progression summary was shown in the PPT. So among the 8 epochs for each language, I have listed the epoch with best validation accuracy and validation F1. So this is my class-wise performance for Kannada language. So the overall performance of precision 0.8 and recall was of 0.49, and F1 score was 0.53. But still it tends to under recall certain underrepresented classes like incorrect quantities. And in the class-based performance of Tamil, I have got overall precision of 0.52 and overall recall of 0.36 and overall F1 of 0.39. These results suggest that while predicting or moderately precise, the model still under-predicts several true positives, particularly in less frequent misinformation categories like incorrect quantities and fabrication. And this is for the class-based performance of Telugu language, where I got overall precision of 0.63 and recall of 0.43, F1 of 0.48. So as a conclusion, we developed a fine-grained misinformation system, especially for low-resource South Indian languages, unlike binary classification. And we leveraged the use of IndiQuad V2, as the IndiQuad V2 model was pre-trained with a lot of Indian languages. And we implemented macro F1 optimization to handle the moderate class imbalance. So we fine-tuned for a model for 8 epochs with the optimal hyperparameters, and this methodology foundations for future low-resource multilingual NLP applications. So these are the references I undergo. Thank you.
Okay, let's thank the speaker. Are there any questions? Quick question? If not, then thanks for presenting, and I will ask the next speaker, Evolved, to
So sharing their screen and get started with the presentation whenever you are done. You can see
Alright.
your screens whenever you are ready.
Perfect. Thank you. Hello, everyone. My name is Thibaut Erard. I am a research engineer at Eurecom, and I'm going to present our work on misinformation detection in Russo-Ukrainian conflict tweets, which is part of the PROMID Shared Task 3. And this work was done with the Climate Sense project, which is a European research project designed to combat climate-related misinformation. So social media has become a major vector for misinformation during the geopolitical crisis, and the Russo-Ukrainian conflict has generated a massive amount of misleading and false content. And so the Shared Task 3 challenges us to detect this misinformation automatically. And the main challenge we faced during this task is an extreme class imbalance where only about 1% of tweets are misinformation. And this causes standard transformer models to overfit on the limited positive examples, and they fail to generalize to new misinformation patterns. So our approach addresses this through targeted data augmentation using an external Ukraine-related misinformation source, which I will describe in detail shortly. Now, let me highlight a few statistics about the data set. So on average, the misinformation tweets are longer with 211 characters compared to 180 for the genuine tweets. They are also predominantly written in English with around 70% versus the 49% for the genuine tweets. They also contain substantially richer metadata with an 81% fill compared to the 53. Although it is important to stress that our approach does not rely on these metadata, and the classification is based exclusively on the content of the tweet itself. In addition, the dataset is extremely unbalanced, as I said, and there are only 364 misinformation tweets compared to the approximately 34,000 genuine ones, which makes it very difficult for models to learn the generalizable features. So our architecture is pretty straightforward. We use a Roberta large, which has 355 million parameters as the base encoder. The input text is tokenized with a maximum length of 256 tokens and passed through the encoder. We then take the CLS embedding, apply dropout with a probability of 0.1, and then we feed it into a linear layer that produces the binary predictions using a softmax. To handle the class imbalance, we implement two key strategies. First, we compute the weighted cross entropy loss, which gives us a weight of 3.67 for misinformation and 0.58 for genuine tweets. Second, we apply the weighted random sampling during the training to balance the actual batch composition. Our hyperparameters are fairly standard with a batch size of 16, learning rate of 2e-5 with linear decay, the Adam W optimizer with 0.01 weight decay, 10% warm-up, and 4 epochs. We used a NVIDIA L40S with 48 gigabytes of memory to train the model. Now, the key contribution, which is our data augmentation pipeline. So for that, we sourced the additional data from the fact-checking observatory, which contains over 6 million Ukraine-related tweets collected from November 2021 through June 2023. Our filtering process has 3 steps. First, we select only the tweets with a misinformation rating of -1, which indicates completely false claims. We then also remove the fact-checking URLs and keep only the false claims themselves. Second, we clean the data by filtering for English-only content and removing the duplicates, which yields about 5,000 unique misinformation tweets. Finally, we combine this with the PROMID data, which increases the misinformation samples by a factor of almost 15x, which shifts the class distribution from 1% to 13.6% misinformation, which is much more manageable for the model training. So here are the main results comparing the baseline model trained only on the PROMIT data versus our augmented model. So the baseline achieves very high precision at 97.6%, but critically the recall is only 30%, which means that it detects only about 1 in 3 misinformation tweets, which is a clear evidence of like the overfitting to the 364 training examples. Now, the augmented model shows a substantially better balance. The precision drops slightly to 90.4%, but the recall improves dramatically to 56%, which is a 83% relative improvement. The F1 score for misinformation jumps from 0.47 to 0.70, and the weighted F1 increases from 0.85 to 0.91. So the interpretation we can make is that the baseline overfits and only flags the most obvious cases, while the data augmentation enables more generalization to diverse misinformation patterns that the model hasn't explicitly seen during the training. We also conducted a detailed error analysis to understand where the model succeeds and where it struggles. So on false positives, we see issues with political commentary, where strong opinions get misclassified as misinformation. We also see sarcasm and rhetorical questions confuse the model. For example, Ukraine has already won, being flagged as incorrect. The meta discussion about deleted content or moderation triggers also false alarms, and non-English content shows higher false positive rates due to our English-only augmentation. On true positives, the gains are substantial. The model now successfully detects conspiracy theories about bioweapon labs, fabricated relationships, propaganda techniques, military claims, and coordinated narratives that appear across multiple accounts with slight variations. And so the key implication is that the augmented model seems to learn diverse misinformation patterns, and we consider the 7.2% precision loss to be an acceptable trade-off for the 83% recall improvement. However, the English-centric augmentation does affect the multilingual performance. So to conclude, our main findings demonstrate that the data augmentation effectively mitigates the extreme class imbalance. Using just 5,000 additional domain-relevant examples, we achieve substantial performance improvements with F1 increasing from 0.47 to 0.70. Our key contributions are first a systematic comparison showing how augmentation solves the severe class imbalance. Second, the fact-checking observatory integration methodology for the Ukraine misinformation. And third, the empirical demonstration that targeted augmentation improves the recall while maintaining high precision. Now, future directions include integrating the user metadata from the data sets to see if it has an impact, using multilingual models like XLMR, combining also multiple models through ensemble methods, and conducting interpretability analysis to better understand the decisions from the model. Thank you for your attention.
Let's sign up today. Any questions for the speaker on the room? So, I want to ask about export resolution, which are used in this training. Like, is it like a movie sort of these data set or like a similar data set that you have been using for part?
I'm sorry, I'm having audio issues. It's very hard to hear.
Yeah, maybe the session chair can repeat the question, because if it's coming from the room, it's very hard to hear.
I'm going to ask you this all the question, but if not, then I think the question was like, what was the source of the data augmentation? Was it like news articles or anything else?
The question is about the source, the additional data set we use.
Yes. That's the question, right? Yes.
Thibault, you want
So
to answer?
oh, yeah. So the question of, okay, the source, so it's coming from the fact-checking observatory, which I believe has as an effort to track misinformation and the impact of misinformation using I believe like professional fact-checking on social media.
Exactly correct. So this is the effort of the past European projects. You can check out on the web fact-checking observatory that was funded by the European Commission, and it's a very large data set collected over 3 years that contains a lot of additional information. So this is what we partly use.
Thank you. I think in the interest of time, we'll just move on to the next speaker. So my task is also same from misinformation detection, which is therefore we are speaking that the CFA complete. The dataset which we have for this is very uneven dataset, and let me. So this is the dataset we have. The misinformation dataset is very less, and the main problem here is the model become very lazy. So in real world also, if we have in real world also the misinformation class is very less. So if we only take the non-misinformation class, so the model will always predict 90% accuracy, and the model will always predict the right data. So here we have so what we So what we did is we had some dynamic threshold optimization which we did. So instead of always choosing 0.5 as the base class, we have chosen from 0 to 1. We have gone from 0 to 1, and based on the with all harmonic growth, we have took the maximum F1 score. So based on that, we classify whether it is misinformation or it is non-misinformation. So as the dataset is not balanced, so what we did is we implemented weighted cross entropy loss. So we penalize the model based on the ground truth, whether if it not identify the misinformation correctly. So what it did is based on the weight cross entropy, back propagates and update the weights accordingly, so that it will means there is a heavy penalization for the model if it is not detecting the minor class correctly. And gradient accumulation, as we have some limitation of the GPU. So instead of taking the smaller size, what we did is we take the 88 weights at a time, and then we have not updated the weights, but we have corrected, we have missed 8 multiplied by 8. So we have done after 8 iterations, we update the weights. This is one of the and we have used the Roberta based model. What we did is we did some data cleaning, like we have instead of in the dataset we have is the URLs, we have some user database. So we have replaced everything with the user so that the model will not be biased. So so yes. So based on that, we have done some data cleaning, and then we have used the robot based model. Then
based on the misinformation. If it is not identifying the correct misinformation, it is very propagating. So this is the result of the prominent data set. We explored the fourth result where we have achieved the advanced score of 0.88. So here the data set is in multi-language. So we have converted everything to the English language. So in future what we can explore like how we can use the different languages instead of English. So thank you.
Next time the speaker. Any questions? I think your approach is quite interesting because we're trying to vary the threshold. There's some kind of a model calibration that we're trying to do, right? So do you have any plots where you have shown like how does your accuracy vary when you are varying the threshold? It's there in your paper, right? So can we go next to you? Brilliant.
Good evening, everyone. So I'm Priyank Sharma, and I'm currently working as an associate professor in the platform. I'm going to present my approach towards the classifying of the problem as a contrasting system for detecting misinformation in these. So, okay, so first a brief of my approach. I am designing a memory efficient pipeline combining a frozen robot encoder with a dual branch network. One is a standard classification system based on binary cross and copy loss, and the second is going to be a contrasted system based on something called a contrasted loss. So this is actually an adaptation of supervised constructed learning, which has been proposed by Dr. Pranay Shukla and another author called Tim Chang back in 2008. So I tried implementing that approach for contrast learning or data set. So I'll be talking about a little bit about the result that I've achieved. Like my approach achieved around 82% weighted advanced score on the test set, and I achieved the 5th position. But I also want to mention here that I have essentially frozen my entire algorithm model because I wanted to execute this within a very limited GPU resource. So like, I was using a free Kaggle account. So if we are in a position to like create a whole pipeline, I think there's definitely scope for further. So I think we have already like, talked about our data sets. I'll skim through this super quick. So the task is classifying tweets as to whether they are spreading misinformation or they are not. So misinformation class is positive class and the other one is negative class. And my aim is to implement contrastive learning here, that is try to like maximize the class separation between the samples. So positive samples should be having environments that are closer to each other in the embedding space, and then the opposite classes should be having vectors which are as far as possible in terms of semantics embedding. So a little bit about the data set, like the original data set had around 364 positive samples misinformation versus 34,000 misinformation
samples. Like, of course, like we were using a weighted F1 score to evaluate on our test data set, but I thought of like downsampling the negatives because the classic balance was like significantly high. So the final split that I have used is 364 misinformations versus 364 non-misinformations. That's amounting to 720 samples from training data. And thereafter, like I have taken like 80% for training, 20% for validation. And the test data set that we had with us was having around 2,440 samples. Okay, so this is just a summarization of the DSL statistics that I just talked about. So now I'm going to talk about the methodology that I followed. I took Robert Base encoding that was frozen because of resource sections. And after extracting my embeddings from the Robert model, I'm then mean coding because I want to convert the whole token level embeddings into a single vector embedding that I'm going to use in my next dual branch classification system. So the upper branch is a projection head, like standard MLP, but using JEDU activation instead of Prelude because I want to avoid the time value problem. And after I'm taking the projection out of this, I'm going to use the contrastive loss as my metric. And then the lower branch is a standard classifier based on normal binary classifier loss, but I'm using the same JEDU activation only. And exactly, the map propagation is going to be based on both the loss components. So map propagating like a combination of binary loss and entropy loss, some with a weighted component from contrast loss instead. So this is like a brief architecture showing my pipeline. First, I have the log reads of the CSV files, misinformation plus non-misinformation. I'm doing some pre-processing, like cleaning data, dropping the empty reads, and then passing it to the Robert model, getting the tokens out of it. Then setting up the tools, Robert encoder, extract the encodings from it, applying mean coding, using attention mask so that the zeros will cancel out all the padding tokens, and we will have like a single vector representation instead of individual token level events. And once I have a single vector representation of it, I'm going to pass it to a classifier head at the top. That does follow the binary loss and entropy loss, and then the projection head at the bottom does follow the supervised contrast loss. And finally, we have a joint optimization, which is going to take like equal weightages from DC loss and contrastive loss. I'm going to show from the application study as to why I took this approach, but these are like two different coefficients, alphas and betas, which can be modified, and this is what I got from validation data. So let me just do like a theoretical overview of what contrastive learning is. So contrastive learning is going to try adjust the vector embeddings in such a way that similar samples could be as close as possible in the n-dimensional vector space, but the opposite classes should be as far apart as possible. So if you're like computing the cosine similarity, like similar vectors which are pointing in the same direction would be having like very minimum angles in between them. So cos 0 would be like as high as possible, and then opposite vectors which are as far apart as possible from each other, they would be having like a huge angle between them. So that means cosine of a very big angle comes to like goes down to 0. So this is the formula which Dr. Tim Chen has used in his supervised contrastive learning paper back in 2020. Right? If we try to understand it, like he has visualized all the samples in a particular Mini batch as anchor. So I'm going to take one anchor and compute the contrastive loss corresponding to that using this expression. So like in the inside, we have like ZI transpose dot ZE, that's like computing the cosine similarity of ith anchor bit
each positive sample that's present in that new batch. So in that new batch, if I'm taking I as an anchor, all the other samples which are having the same target label would be the peak classes. Like here, I'm not considering this information or not this information. Same class is P, different class is negative. So we also have like a division by a temperature parameter here, right? If you look at the formula, so there's a division by tau. Tau stands for division. So if you have like a very high value of temperature, then automatically like the cosine similarity would not be able achieving after like multiplying the vector embeddings, that's going to reduce in strength. So I have used like 0.07 as temperature parameter. So this means that I'm going to get like a very high contribution of this cosine similarity component. Now for the total contrasted loss, like one thing I would highlight here is that I've divided this by 2 n. So this means from the original Robert model, I took like two from the projection head out of that Robert model, I took like 2 different views from that same sample. So this is to some extent using kind of augmentation, because whenever I'm going through that projection head, because there's dropout, in some way like the 2 views that I'm generating will be little different. So that's to some extent that is to implement a sort of augmentation, because we have like very limited data set after the downsampling is performed. And for binary cross entropy loss, we have the similar like we have the traditional formula. And final loss is like an alpha component times contrastive loss plus beta component beta times binary cross entropy loss. And the coefficients that I have used is alpha beta both should be 1. And I'll be showing from the ambition study as to how this is giving us optimal results. So these are like implementation details. I'm not going to go through this because these are like details which we would need in order to reproduce the results. Now we have like some validation dynamics, like learning rate is getting reduced because we have early stopping callbacks. We don't want the learning rate to stay the same even though there's improvement. And then if you look at the loss curve, like the orange one is like the contrast loss, it's increasing very, very strongly. And the green one is like the classifier loss, which is decreasing, but it did not decrease as rapidly as the contrast loss. And then for the F1 precision recall curves, like F1 is definitely precision and F1 curves are definitely rising steadily, but recall is sort of unstable. So, yes, for the final evaluation, like I just did on the 2024, these are the on the test data set, and for non-misinformation, precision was very high, like 96%, but for misinformation, precision was a little lower, 46% versus recall was significantly higher. This means that of all the misinformations present, we were able to like predict 83% of it, but of all the misinformations that we were predicting, just 46% of it was actually correct. That means this architecture has developed some kind of tendency to over-predict the misinformation class. So that's one of the limitations of our approach. Now, this is like an application study where I have like tweaked with the coefficients of alpha, beta, like just using the classifier, it's giving me like 67% form. Just using the contrastive branch, just giving me a very low value, like just 9% form. And when I'm using both of these branches in a 50-50 contribution, I'm getting like 79%. But when I'm like using like a alpha and beta both as 1, I'm getting like around 84% advanced score. So that was giving me the highest result. And now like I think like for coefficients, you can definitely go for that 1 because these are not probabilities. So the sample doesn't have to be 1. So this is what I identified, and this was very good at hackathon. And
Yes, like this is like from Henry Angus' perspective, like this is what I already iterated before. My architecture is telling to overbreak the misinformation loss. The positives are coming more from reads, especially from those which are quoting or criticizing misinformation, stressing on those aspects. And also, like very short reads are those reads which are having like just a word or just an image or sort of misclassified because the pipeline is lacking awareness regarding how to navigate the URL or how to decode that image. So as a further improvement, as an action item for me, would be to unfreeze the encoder and see how much better performance I'm getting out of this. So yes, like these were some of the limitations. I had a very small training set after big or something, and because I was freezing the encoder, I was not getting the full potential of my pipeline. So like, as a conclusion, like I would say that my pipeline is like not the state of the art, of course, but there's definitely potential for further enhancement because we have like once we are using like good amount of compute resources. So yeah, that's it. That's it from my side. Thank you. Thank you. Next time. Question on the speaker.
So it's actually for interesting because I think you didn't try out the unequal contribution of both the branches.
Yes.
So you tried out 0.5, 0.5, and 1.1. But 1.1 was not better than 0.5.
Yes.
Which makes me think that if you had tried out something like 110.
I did try out a few operations that I not recorded all of them, but they were not getting seriously higher. So I mean, I was also like I joined and become very late, so I didn't have much time also. But I would love to have a further separate scheme. This can also be one of the actions of the this can also be like some there can be further scope out of these modifications.
Oh, we have a question.
In your error analysis, we know that there was false positive rates and there was image misclassification. So, in your future, how are you going to deal with this?
For images, like we definitely have to have like image classifiers. We have to probably have to involve agents for that. I mean, like want to work on the URLs. For this case, like how we work on the reads, have not taken into account any of the URLs. Select the URLs that were present in the dataset. And also, like for most of them, like I think the URLs were absent as well. Like, it was just for a few of them. We have the URLs. So that's also one of the action items. We can definitely incorporate agents. Maybe one studies the URLs, maybe one studies the images, and we get like a combined effort from different agents. That's how we can further enhance the predictions. So that kind of figure again.
Okay, so with this we conclude our second day at Fire. So we hope to see you again tomorrow morning. And we're going to have a steering committee meeting at this room. So we'll just have a closed session.